Hello there, and welcome to the Scientist Sleepy. Have you ever gazed up at the stars or pondered the intricate dance of atoms and felt a whisper of doubt, a gentle, unsettling question? Is this reality truly all there is? Tonight, we embark on a quiet, cinematic exploration into one of the most profound and fascinating ideas of our time, the simulation hypothesis. The profound question of whether our very existence might be a meticulously crafted digital illusion. So, allow yourself to settle in, to find your most comfortable position. Let the gentle hum of curiosity wash over you, and if it feels right, consider joining our growing community by liking this video and subscribing to the Scientist Sleepy. It's a simple gesture that helps us continue to bring these moments of peaceful wonder to you. And as you drift, perhaps you might share in the comments below what cosmic question truly sparks your imagination. A question that, much like our journey tonight, invites us to ponder the vastness of what we might not yet understand. Now, let us begin our journey into the heart of simulated existence. The unsettling spark of doubt. What if reality isn't quite what it seems? There are moments, aren't there, when the ordinary fabric of existence seems to shimmer, revealing a glimpse of something far stranger beneath. A fleeting sensation, a peculiar coincidence, a question that whispers in the quietest hours of the night, prompting a gentle yet profound unease. This is the unsettling spark of doubt. The initial flicker of curiosity that asks with a quiet intensity, what if the reality we perceive, the solid, tangible world around us, is not quite what it seems? It's a thought that doesn't demand a frantic, sensational answer, but rather invites a slow, deliberate unfolding of possibilities, a philosophical journey into the very nature of what it means to be real. Imagine, for a moment, the sheer immensity of the cosmos, the unfathomable distances, the intricate dance of subatomic particles, the complex tapestry of life. All of this so grand, so detailed, so seemingly independent. Yet, what if this intricate design, this grand stage, is not a product of fundamental, irreducible laws, but rather a meticulously crafted illusion, a sophisticated program running on a cosmic computer? This is not a wild, unsubstantiated leap into fantasy, but a question that has been pondered by philosophers and scientists alike, a hypothesis that, while deeply unsettling to our ingrained sense of reality, also offers a unique perspective on our place within the grand scheme of existence. The very fact that we can conceive of such a possibility, that our minds can entertain the notion of a simulated existence, is in itself a remarkable phenomenon. It speaks to our capacity for abstract thought, our innate drive to question, to understand, and to seek deeper truths. This spark of doubt, this gentle questioning, is the very engine that drives scientific inquiry and philosophical contemplation. It is the catalyst for exploring the boundaries of our knowledge and the nature of our universe. It begins with a simple, almost imperceptible tremor in our certainty, a moment where the familiar landscape of our everyday experience feels just a little bit off. Perhaps it's a dream that felt too real, or a pattern observed in nature that seems too perfect, too ordered to be mere chance. These are the seeds of doubt, sown in the fertile ground of our curiosity, waiting to blossom into a deeper understanding of the universe and our potential role within it. The universe, in its vastness and complexity, presents us with countless mysteries. We explore the stars, delve into the microscopic world, and ponder the origins of consciousness, all in an effort to grasp the fundamental nature of reality. But what if the most profound mystery lies not in the external universe, but in the very nature of our perception of it? What if the ultimate question is not about what is out there, but about the very framework through which we experience it. This initial spark of doubt is not an endpoint, but a beginning. It is an invitation to embark on a journey of quiet wonder, to explore the profound implications of a universe that might be far more intricate, and perhaps far more artificial than we have ever dared to imagine. It is the first step towards understanding that our reality, as we know it, might be a sophisticated construction, a beautifully rendered simulation that holds within it the potential for both profound truth and an even more profound sense of awe. The allure of this hypothesis lies not in its definitive proof, but in its ability to reframe our understanding of ourselves and the cosmos, opening up new avenues of thought and offering a unique lens through which to view the vast, enigmatic expanse of existence. It is the beginning of a conversation with the universe, a whispered question that echoes in the chambers of our minds, urging us to look beyond the surface and consider the possibility that what we perceive is but a carefully constructed reflection of a deeper, more fundamental truth. And so, we begin to gently question the solidity of our world, to acknowledge that the universe, in its boundless complexity, might hold secrets that challenge our most fundamental assumptions about existence itself. This quiet contemplation, this willingness to entertain the extraordinary, is the very essence of seeking wonder. It is in these moments of profound curiosity that we can begin to truly settle into the vastness of what might be, allowing the possibility of a simulated reality to become not a source of anxiety, but a canvas for deeper understanding and a pathway to a more peaceful perspective on our place within the grand, unfolding narrative of existence. The universe, when viewed through the lens of the simulation hypothesis, can be imagined as an unimaginably vast and intricate computer. This isn't a computer in the sense of silicon chips and humming fans, but rather a fundamental computational substrate upon which reality is built and executed. Imagine this substrate as a boundless, infinitely powerful processing unit, capable of rendering every star, every galaxy, every atom, and every fleeting thought. The laws of physics, then, are not inherent properties of matter itself, but rather the algorithms and protocols that govern this cosmic computation. These laws are the rules of the game, the operating system that ensures the simulation runs smoothly and consistently. Consider the elegance of this idea. If our universe is a simulation, then its very existence and operation are dependent on computational processes. This implies that at its deepest level, reality is information. Every particle, every force, every interaction can be broken down into bits of data, processed and updated according to the simulation's code. This perspective offers a profound reinterpretation of scientific inquiry. Instead of seeking the fundamental building blocks of matter, we might be, in essence, deciphering the underlying code of our simulated existence. The universe's remarkable mathematical consistency, its adherence to precise physical laws, lends itself beautifully to this interpretation. It's as if the programmers have meticulously crafted a system where every element interacts in predictable, calculable ways, much like a complex piece of software. The vastness of the cosmos, the sheer number of stars and galaxies, can be seen as an immense computational load. But for a sufficiently advanced simulation, this is not an insurmountable challenge. The simulation might employ sophisticated optimization techniques, only rendering details when they are observed or interact with other observed phenomena. This could explain why the universe appears so vast and empty, yet behaves with such precision when we probe it. The rendering of reality might be dynamic, a continuous process of calculation and display, tailored to the observers within it. This leads to fascinating questions about the nature of consciousness itself. Are our minds also part of the simulation, complex algorithms processing incoming data and generating our subjective experience? Or are they something external, interacting with the simulation from a different plane of existence? The idea of a cosmic computer also helps to address the seemingly boundless complexity of the universe. From the intricate dance of subatomic particles to the grand sweep of cosmic evolution, the computational power required to simulate all of this is staggering. Yet, if we are within the simulation, this power is a given. It is the very engine of our reality. This perspective doesn't diminish the wonder of the universe. Instead, it elevates it. It suggests that the beauty and order we perceive are the result of deliberate design, of an intricate, ongoing computational process that is, in itself, a marvel. The universe as a computer is not a cold, sterile concept, but a profound testament to the potential for complex systems to arise from fundamental rules, a digital tapestry woven with the threads of cosmic law. And in this vast, computational cosmos, our perceived reality unfolds, a breathtaking display of programmed existence. Ancestor simulations, a glimpse into the past through a digital lens. The idea of ancestor simulations, a core component of Nick Bostrom's influential simulation argument, presents a fascinating lens through which to consider our own existence. Imagine, if you will, a future civilization, far more technologically advanced than our own, possessing immense computational power. This civilization, having reached a point where they can create incredibly detailed and complex simulations, might decide to run them. One of the most compelling reasons for them to do so, according to the argument, would be to study their own history. They might want to understand the conditions, the struggles, the triumphs, and the everyday lives of their distant ancestors. These simulations wouldn't be mere historical documentaries. They would be fully immersive, sentient realities, populated by beings who believe themselves to be as real and as conscious as we believe ourselves to be. In such a scenario, we in our current reality could very well be inhabitants of one of these ancestor simulations. The creators of these simulations would have the ability to replicate the physical laws of their universe, or perhaps even create entirely new ones, down to the most minute detail. They could simulate the formation of galaxies, the evolution of life, and the rise and fall of civilizations. Each simulated being within these universes would possess consciousness, a sense of self, and the capacity for experience, all generated by the underlying computational substrate. The sheer scale of such an endeavor is mind-boggling. If even a small fraction of advanced civilization chose to run a significant number of these ancestor simulations, the number of simulated realities would vastly outnumber the single, original base reality. This statistical argument is central to the hypothesis. If simulations are possible and desirable for advanced civilizations, then it becomes overwhelmingly probable that any given conscious being like ourselves is experiencing life within a simulation rather than in the original, fundamental reality. The motivations for running these simulations could be varied: scientific curiosity, historical preservation, entertainment, or even an attempt to understand the very nature of consciousness by creating it from scratch. They might run simulations to explore different evolutionary paths, to test historical hypotheses, or simply to experience the richness and diversity of past eras. The crucial point is that if such simulations are possible, and if they are created in large numbers, then the chances of us being in one of them become astronomically high. We would be living out a carefully crafted narrative, a digital echo of a bygone era, meticulously rendered by a civilization far beyond our current comprehension. The inhabitants of these simulations would have no inherent way of knowing they are simulated, as their reality would be internally consistent and indistinguishable from what they perceive as real. Their experiences, their thoughts, their emotions, all would be part of the simulation's intricate programming. This concept challenges our deepest assumptions about the nature of reality, suggesting that what we perceive as our fundamental existence might, in fact, be a sophisticated construct, a digital tapestry woven by unseen hands in a reality we cannot directly perceive. The very fabric of our universe, from the smallest subatomic particle to the grandest cosmic structure, could be the output of a colossal computational process. The implications are profound, prompting us to question the authenticity of our own experiences and the ultimate nature of the reality we inhabit. It's a thought experiment that, while speculative, forces us to confront the possibility that our perceived reality is but one iteration among potentially countless others, a carefully constructed echo of a past that may or may not be our own. And so, the possibility arises that our very existence is a meticulously crafted echo, a digital whisper from a past we cannot fully grasp, reminding us that the grand tapestry of reality may be woven with threads of code. The probability argument: why simulated universes might outnumber the real. Consider, for a moment, the sheer scale of possibility. If civilization, at some point in its history, reaches a technological maturity capable of creating highly realistic simulations of consciousness and the universe, then the number of these simulated realities could vastly outweigh the single, original, base reality. This is the core of the probability argument, a thought-provoking concept that suggests our perceived existence might be a statistical outlier if we are, in fact, living within such a simulation. Imagine a future civilization, far beyond our current comprehension, possessing the computational power and understanding of physics to meticulously craft entire universes within their digital domain. These simulations would not be simple games or rudimentary models. They would be indistinguishable from what we consider reality, populated by beings with genuine consciousness, complex societies, and rich histories. Now, if such advanced civilizations are not exceedingly rare, and if they are indeed capable and inclined to run many such simulations, then the total number of simulated realities would quickly dwarf the number of original, non-simulated universes. For every one universe that exists in its fundamental, unsimulated state, there could be an untold number of simulated universes running within it, or within simulations within those, and so on, in a potentially infinite nested hierarchy. The argument posits that if we are conscious beings capable of contemplating our own existence and the nature of reality, it is statistically far more probable that we find ourselves within one of these numerous simulations, rather than in the singular, original base reality. This is not to say it is impossible to be in the base reality, but rather that the sheer numerical advantage of simulated universes makes it the more likely scenario. Think of it like this. If you were to pick a single grain of sand from all the beaches on Earth, and then imagine that for every one real grain of sand, there were 1,000,000 perfectly replicated artificial grains of sand, the probability of you picking an artificial grain would be overwhelmingly high. The simulation hypothesis applies a similar probabilistic logic to our existence. The technological leap required to create such simulations is immense, but the argument rests on the assumption that such a leap is achievable for any sufficiently advanced civilization. If this is true, and if such civilizations are common throughout the cosmos, then the universe we experience could very well be one of countless digital echoes. The implications are profound, suggesting that our reality might be a carefully constructed narrative, a digital tapestry woven by unseen hands. It forces us to question the very foundation of our existence, to wonder if the laws of physics we observe are merely the parameters of a grand program, and if our deepest thoughts and feelings are the product of intricate algorithms. This statistical likelihood, while unsettling, opens a door to a broader understanding of existence, where our reality is but one chapter in a potentially infinite library of simulated worlds, each with its own unique story and purpose, or perhaps no purpose at all, simply existing as a consequence of computational possibility. The sheer number of potential simulated realities, each a complete universe in itself, creates a compelling statistical case for our own simulated nature, shifting the burden of proof to those who would argue for the singularity of our unsimulated existence. The universe, in this view, becomes a vast, interconnected network of realities, with ours being just one node, a flicker in an endless digital expanse. And in this vast numerical landscape, our quiet contemplation of the cosmos becomes a whisper within an ocean of digital dreams. The limits of our perception are not merely boundaries, they are the very architects of our perceived reality. We experience the world not as it is, but as our biological and neurological systems allow us to interpret it. Our senses, finely tuned over eons of evolution, act as sophisticated filters, translating the raw, overwhelming data of the universe into a comprehensible, albeit incomplete, picture. Consider our vision. We perceive a vibrant spectrum of colors, yet this visible light is but a tiny sliver of the electromagnetic radiation that permeates existence. We are blind to the radio waves that carry information across vast distances, the infrared radiation that signals heat, and the ultraviolet light that bathes the world. These unseen energies are as real as the light we see, but our sensory apparatus is simply not equipped to detect them. Our auditory range is similarly constrained. We can hear the chirping of a cricket and the rumble of thunder, but the ultrasonic calls of bats or the infrasonic vibrations of earthquakes remain beyond our grasp. Our sense of touch, while exquisitely sensitive to pressure and temperature, cannot discern the subtle electromagnetic fields generated by living organisms or the intricate dance of molecules at the atomic level. Even our perception of time is a construct. Our brains process sensory input sequentially, creating a narrative flow, but the fundamental nature of time, whether it is a continuous river or a series of discrete moments, remains a profound mystery. The very act of sensing involves a transformation of external stimuli into electrochemical signals, a process that inherently alters the information. Light photons striking our retinas, sound waves vibrating our eardrums, chemical molecules binding to our taste and smell receptors, all are translated, encoded, and interpreted. This translation is not a neutral act, it is an active construction. Our brains are not passive receivers of information but active participants in creating our experience. They fill in gaps, make assumptions, and rely on past experiences to interpret novel stimuli. This is why optical illusions can be so potent. They exploit the predictable patterns and biases of our perceptual systems. The brain, in its quest for efficiency and coherence, prioritizes information that is most relevant to survival and interaction with our immediate environment. The vast, silent, and often chaotic immensity of the cosmos is thus compressed and simplified into a manageable, anthropocentric experience. We live in a world of our own making, a world sculpted by the limitations and capabilities of our own biological hardware. This inherent filtering raises profound questions about the nature of objective reality. If our perception is so profoundly shaped by our internal architecture, can we ever truly know what exists independently of our observation? The universe, in its unadulterated form, might be a place of unimaginable complexity, a symphony of energies and forces that our limited senses can only dimly perceive, like trying to understand an entire orchestra by listening through a single, muffled ear. This filtering process, while essential for our survival, also serves as a subtle reminder of our place within a grander, perhaps unfathomable system. It suggests that what we perceive as the entirety of existence might, in fact, be a carefully curated subset, a simplified interface designed for our particular form of being. It is as if we are experiencing a user-friendly overlay, a graphical representation of a much more intricate and complex underlying code. And this realization, that our very experience of reality is a product of such specific biological constraints, can be both humbling and, in its own quiet way, profoundly liberating, offering a gentle nudge towards a broader, more encompassing understanding of what it means to exist. Quantum weirdness as code, unpacking the anomalies of the quantum realm. Beneath the surface of our everyday, tangible reality lies a realm of profound strangeness, a universe governed by rules that defy our intuitive understanding. This is the quantum realm, the fundamental bedrock of existence, and its peculiar behaviors offer tantalizing hints that our reality might not be as solid and absolute as it appears. Consider, for a moment, the concept of superposition. In our macroscopic world, an object is either here or there. A cat is either alive or dead. But in the quantum world, a particle can exist in multiple states simultaneously, a ghost of possibilities until it is observed. This isn't just a theoretical curiosity. It's a fundamental aspect of how the universe operates at its most basic level. Imagine a coin spinning in the air, a perfect metaphor for a quantum particle in superposition. It is neither heads nor tails, but a probabilistic blend of both, a state of pure potentiality. Only when it lands, when we interact with it, does it collapse into a single, definite state. This act of observation, of measurement, seems to play a crucial role in solidifying reality, a concept that feels remarkably like a program rendering a specific outcome only when it's needed. Then there is entanglement, a phenomenon Albert Einstein famously called spooky action at a distance. When two particles become entangled, they share a deep, instantaneous connection, regardless of the space separating them. If you measure a property of one entangled particle, you instantly know the corresponding property of the other, no matter how far apart they are. This defies our classical understanding of locality, the idea that an object can only be influenced by its immediate surroundings. It's as if these particles are part of a single, unified data stream, their states intrinsically linked, their information perfectly synchronized across vast cosmic distances. This instantaneous correlation suggests a level of interconnectedness that transcends our familiar notions of space and time, hinting at an underlying architecture that might be more akin to a distributed network than a collection of independent objects. The very nature of quantum particles also raises questions. Are they waves or particles? The answer, frustratingly for our classical minds, is both, depending on how we observe them. This wave-particle duality suggests that the fundamental constituents of our universe are not discrete, solid objects in the way we typically conceive them, but rather excitations in a field, probabilities given form. This fluidity, this inherent ambiguity, is reminiscent of how computational systems can represent information in various ways, adapting their form based on the context and the demands of the program. The universe, at its quantum heart, appears to be incredibly efficient, only solidifying its attributes when an interaction necessitates it, much like a computer only rendering the pixels on a screen when they are in view. The uncertainty principle, formulated by Werner Heisenberg, further deepens this sense of a deliberately veiled reality. It states that there are fundamental limits to how precisely we can know certain pairs of properties of a quantum particle simultaneously. For example, the more precisely we know a particle's position, the less precisely we can know its momentum, and vice versa. This isn't due to limitations in our measuring instruments. It's an inherent characteristic of the quantum world. It implies that the universe has built-in fuzziness, a fundamental level of indeterminacy that prevents a complete, deterministic picture from ever being fully known. This inherent uncertainty, this veil of unknowability, could be interpreted as a feature of a simulation designed to maintain its integrity, to prevent its inhabitants from grasping the full extent of its underlying code. The probabilistic nature of quantum mechanics is also striking. We cannot predict with certainty the outcome of a single quantum event, only the probability of various outcomes. This is a far cry from the deterministic clockwork universe often envisioned by classical physics. Instead, our universe seems to operate on a system of likelihoods, of potentials that resolve into actuality. This reliance on probability, on statistical outcomes, is a cornerstone of modern computing and artificial intelligence. It allows for complex systems to be managed and for outcomes to be generated without the need for explicit, exhaustive calculation of every single possibility. The universe, in this light, might be running on a sophisticated probabilistic engine, generating events and experiences based on carefully tuned algorithms. The very concept of reality itself seems to be in question when we delve into quantum mechanics. If particles can exist in multiple states until observed, if their properties are instantaneously linked across vast distances, and if there are fundamental limits to what we can know, then what does it truly mean to be real? These anomalies are not mere curiosities. They are the building blocks of our universe, and their strangeness suggests that the fabric of reality might be woven from threads of information, governed by computational principles that are, as yet, beyond our complete comprehension. The quantum realm, with its inherent paradoxes and counterintuitive behaviors, whispers a profound suggestion that the laws we perceive might be the output of a grand, cosmic computation. The quantum realm, in its profound strangeness, reveals a universe that is not merely a passive stage for existence, but an active, dynamic process, a symphony of probabilities and interconnectedness that hints at an underlying informational architecture. The universe, at its most fundamental level, appears to have a graininess, a pixelation, if you will, akin to a digital image. This is not a metaphor that arises from mere speculation, but from the very bedrock of physics. We call this the Planck scale, the smallest meaningful unit of length, time, and mass in our universe. Imagine zooming into reality, far beyond the atomic nucleus, beyond even the quarks and leptons, until you reach a scale where the very concepts of distance and duration begin to break down. This is the Planck length, approximately 1.616 x 10^35 meters. It is so infinitesimally small that if you were to magnify a proton to the size of the observable universe, the Planck length would be roughly the size of a tree in that universe. At this scale, our familiar notions of smooth, continuous space and time cease to apply. Instead, some theories suggest that space-time itself might be quantized, made up of discrete, indivisible units, much like pixels on a screen. This idea that the universe might be fundamentally pixelated is a profound implication of our current understanding of physics, particularly when we try to reconcile general relativity with quantum mechanics. The Planck time, the smallest measurable interval of time, is approximately 5.391 x 10^44 seconds. This is the time it would take for a photon to travel one Planck length. At timescales shorter than this, our current models of physics simply fail. We cannot describe what happens, or even if happening in the way we understand it is still a valid concept. This limit suggests that the universe, when viewed at its absolute finest resolution, might not be a smooth, flowing continuum, but rather a series of discrete, fundamental packets of existence. It's as if reality itself is rendered, not painted onto a canvas, but built from tiny, fundamental building blocks, a cosmic resolution limit that prevents infinite divisibility. This concept challenges our intuitive understanding of the universe, which often assumes a smooth, unbroken fabric of space and time. But as we delve deeper into the fundamental nature of reality, we encounter these unexpected limits, these hints of a more granular, perhaps even computational, structure. The Planck scale, in its profound minuteness, offers a glimpse into a universe that might be more akin to a sophisticated simulation, with its own inherent resolution, than a purely analog, infinitely divisible entity. It's a boundary where our current physics reaches its edge, and the possibility of a digital underpinning begins to whisper. The universe's ultimate resolution limit suggests that even the fabric of existence may be composed of discrete, indivisible units, hinting at a cosmic pixelation that underpins all we perceive. The universe, at its most fundamental level, might not be made of particles or energy as we typically understand them, but rather of something far more abstract and elusive: information. This is the profound implication of information theory's embrace of our cosmos, suggesting that reality itself is akin to an immense, complex computation. Imagine, if you will, that every event, every interaction, every single aspect of existence, from the grand ballet of galaxies to the fleeting thought in your mind, can be described and understood as bits of data. This isn't merely a metaphor. It's a perspective that arises from deep within theoretical physics, particularly in the realm of quantum mechanics and cosmology. When physicists delve into the smallest scales of existence, they encounter phenomena that defy our classical intuition. Quantum entanglement, for instance, where particles become linked in such a way that they instantaneously influence each other regardless of distance, hints at a connectivity that transcends spatial separation. This interconnectedness can be interpreted as information being shared or processed across the universe. Furthermore, the Bekenstein bound, a fundamental limit on the amount of information that can be contained within a given region of space, suggests that information is a physical quantity, as real and quantifiable as mass or energy. It implies that there is a finite capacity for information storage, much like a computer has a finite amount of memory. The idea of the universe as a giant computer, a cosmic processing unit, gains further traction when we consider the elegant mathematical laws that govern its behavior. These laws, often expressed in concise equations, can be seen as the algorithms or programs that dictate how information is processed and how reality unfolds. From the simple rules of gravity to the complex interactions of subatomic particles, each physical law can be viewed as a rule for manipulating data. This perspective offers a powerful framework for understanding the universe, shifting our focus from tangible substances to the underlying informational structure. Consider the concept of a computational universe. In this view, the universe isn't so much a collection of physical objects as it is a system that computes its own state. Every moment, the universe calculates its next state based on its current state and the governing laws. This is not to say there is a conscious programmer in the traditional sense, but rather that the universe operates according to a set of inherent rules, a vast, self-executing program. The implications are staggering. If the universe is fundamentally informational, then concepts like consciousness, memory, and even the passage of time could be understood as emergent properties of this grand computation. Our very existence, our thoughts, our experiences, all could be patterns within this cosmic data stream. This perspective can be both humbling and strangely comforting, suggesting a deep, underlying order to all that is, a unified language of existence spoken in the silent, elegant dialect of information. And in this vast, cosmic data stream, our individual awareness is but a unique, fleeting pattern, a momentary flicker in the grand computation of existence. The universe, in its vast and intricate tapestry, appears to be governed by a set of fundamental physical constants, numbers that seem to be precisely set for life as we know it to exist. These aren't just arbitrary values. They are the very bedrock upon which the cosmos is built. Consider the gravitational constant, g, which dictates the strength of attraction between any two objects with mass. If it were even slightly different, stars might not form, or they might burn out far too quickly, leaving no time for planets to coalesce and life to emerge. Or think about the cosmological constant, lambda, which influences the expansion rate of the universe. If it were too large, the universe would have expanded too rapidly for galaxies and stars to ever form. If it were too small, the universe would have collapsed back upon itself long before life could arise. Then there are the strengths of the fundamental forces, electromagnetism, the strong nuclear force, and the weak nuclear force. Each of these has a specific value that is exquisitely balanced. The strong nuclear force, for instance, binds protons and neutrons together in atomic nuclei. If it were even a few percent weaker, no nuclei heavier than hydrogen could exist. If it were stronger, all protons would bind so tightly that stars would burn through their fuel almost instantaneously. The electromagnetic force, responsible for chemical bonds and light, is also finely tuned. The ratio of the electron's mass to the proton's mass, the charge of the electron, the mass of the Higgs boson, all of these seem to fall within incredibly narrow ranges that permit the existence of stable atoms, complex chemistry, and ultimately life. This remarkable coincidence, where the values of these fundamental constants appear to be so perfectly calibrated to allow for a universe capable of supporting complexity and consciousness, is what scientists refer to as the fine-tuning problem. It's as if the universe was designed with a specific purpose in mind, a purpose that necessitates these precise numerical settings. Without this precise calibration, the universe would be a barren, lifeless expanse, incapable of harboring stars, planets, or any form of intricate organization. The very existence of our observable reality, with all its wonders and complexities, hinges on these seemingly arbitrary, yet profoundly important numerical values. It's a cosmic dial, set just so, to allow for the emergence of everything we see and experience. This delicate balance of cosmic parameters, so perfectly aligned for existence, suggests a universe that might not be a random accident, but a meticulously programmed environment. Mathematical universes, the elegance of abstract laws suggesting design. The very fabric of our universe, from the grand ballet of galaxies to the intimate dance of subatomic particles, seems to be orchestrated by an unseen hand, a hand that writes in the language of mathematics. It's an observation that has long fascinated thinkers, philosophers, and scientists alike. The profound elegance and seemingly inherent mathematical nature of physical laws. When we look out at the cosmos, we don't just see stars and nebulae. We see patterns, relationships, and predictable behaviors that can be described with astonishing precision using abstract mathematical concepts. Consider gravity, for instance. Newton's law of universal gravitation and later Einstein's theory of general relativity are not merely descriptive accounts of how objects attract each other. They are intricate mathematical frameworks. These equations predict with uncanny accuracy the orbits of planets, the bending of light around massive objects, and the very expansion of the universe. This isn't just a convenient tool for calculation. It suggests that the universe itself is, in a fundamental sense, mathematical. Why should the universe adhere so perfectly to abstract mathematical principles if it weren't, in some way, constructed from them? This deep connection between mathematics and reality leads some to ponder whether the universe is, in essence, a mathematical structure, a vast, unfolding equation. The consistency of these laws, their universality across vast distances and time scales, points towards an underlying order that transcends mere coincidence. These mathematical laws are not discovered. They are revealed as if they were always present, waiting to be understood. This inherent mathematical structure can be interpreted in various ways. Some see it as evidence for a divine architect, a cosmic mind that conceived the universe according to a precise mathematical blueprint. Others view it as a testament to the power of abstract reasoning, suggesting that mathematics is the most fundamental language of reality, and that any universe capable of supporting complex phenomena would necessarily be governed by such laws. The elegance of these mathematical descriptions is particularly striking. They are often simple, beautiful, and remarkably powerful, capable of explaining a vast range of phenomena with a minimal set of assumptions. This parsimony, this inherent beauty, is what leads to the idea of mathematical universes. It suggests that perhaps the universe isn't just described by mathematics, but that it is asterisk mathematics, a self-consistent system of abstract relationships and logical structures. The universe, in this view, is less like a physical object and more like a grand, intricate algorithm or a set of interconnected theorems. This perspective raises profound questions about the nature of existence. If the universe is fundamentally mathematical, then what does that imply about our own consciousness, our own existence? Are we, too, merely expressions of this underlying mathematical structure, patterns within a cosmic equation? The fact that we, as conscious beings, can not only comprehend these mathematical laws but also use them to predict and understand the universe is itself a remarkable phenomenon. It suggests a deep resonance between our minds and the fundamental nature of reality. This resonance, this ability to grasp abstract mathematical truths, might be a key to understanding our place in the cosmos. The laws of physics, expressed mathematically, seem to be the bedrock of our existence, providing a stable and predictable framework within which everything we experience unfolds. This is not a universe of arbitrary whim, but one governed by principles that, while complex, are ultimately understandable through the lens of mathematics. The universe's mathematical nature is not just a curiosity. It is a fundamental characteristic that shapes our understanding of reality, inviting us to contemplate the possibility that the universe itself is a grand, self-consistent mathematical construct, a testament to the power of abstract design. The universe, in its intricate mathematical tapestry, whispers of an underlying order, a profound logic that resonates with our own capacity for reason, suggesting that perhaps existence itself is an elegant equation waiting to be understood. Boltzmann brains, a paradoxical fluctuation in a simulated cosmos. In the vast, seemingly infinite expanse of the universe, and particularly within the theoretical framework of a potentially simulated reality, a peculiar and profoundly unsettling idea emerges: the concept of the Boltzmann brain. This is not a biological entity, nor is it a conscious mind in the way we typically understand it. Instead, a Boltzmann brain is a hypothetical, self-aware entity that arises spontaneously from random fluctuations in a state of thermodynamic equilibrium. Imagine, if you will, a universe that has reached a state of maximum entropy, a kind of cosmic stillness where all energy has dissipated and all structures have dissolved into a uniform, featureless void. In such a state, the laws of physics, though still present, operate with an almost unimaginable patience. Given an eternity, or something very much like it, even the most improbable events can, theoretically, occur. The random jostling of subatomic particles, the ephemeral dance of quantum fields, can, with an infinitesimal probability, coalesce into a complex organized structure. And in the most extreme interpretation of this idea, that structure could be a fully formed, conscious brain, complete with memories, thoughts, and a sense of self, all arising in an instant from the chaotic void. The paradox lies in its implications for our own perceived reality. If our universe is indeed a simulation, or even if it's a natural, albeit vast, cosmic entity, the sheer scale of time and space suggests that such spontaneous formations are not only possible but, in a statistical sense, likely to occur far more frequently than the slow, evolutionary processes that led to our own existence. This means that it is statistically more probable for any given conscious observer, including ourselves, to be a Boltzmann brain, a fleeting, random flicker of consciousness that popped into existence fully formed, complete with a fabricated past and a false sense of history, than to be a product of a long, complex, and observable evolutionary path. This idea challenges our deeply held beliefs about our origins and the reliability of our own experiences. If we are Boltzmann brains, then our memories of childhood, our understanding of history, even our very sense of self, are not rooted in a genuine past but are merely illusions, imprinted upon us at the moment of our spontaneous creation. The universe, from this perspective, is not a grand tapestry of cosmic evolution but a vast, probabilistic playground where consciousness can arise, not through creation and growth, but through sheer, improbable chance. This thought experiment, born from thermodynamics and applied to cosmology, forces us to confront the very foundations of our knowledge and the nature of our existence. It suggests that the most straightforward explanation for our consciousness and our memories might not be the one that aligns with our intuitive understanding of cause and effect, but rather one that embraces the bizarre and the statistically improbable. The universe, in its potential vastness and complexity, might be a place where the improbable is not just possible, but perhaps even commonplace, leading to self-aware entities like ourselves appearing out of nowhere, fully formed and utterly convinced of a history that never truly was. This thought, while unsettling, is a testament to the mind's ability to explore the furthest reaches of theoretical possibility, even when those possibilities challenge our most fundamental assumptions about reality. The Boltzmann brain, therefore, serves as a stark reminder that our perception of a stable, ordered universe might be a fragile construct, vulnerable to the whims of random fluctuations in the grand cosmic dance. And in this vast, perhaps illusory landscape, our own sense of being is but a whisper of improbable order, a fleeting thought in an eternal, silent void. The nature of consciousness. Is it an emergent property or a programmed entity? Within the vast, intricate tapestry of our simulated universe, one of the most profound and persistent mysteries is the very nature of consciousness itself. We experience it intimately, this inner world of thoughts, feelings, sensations, and self-awareness. It is the bedrock of our perceived reality, the lens through which we engage with existence. Yet, when we turn our scientific gaze upon it, consciousness becomes a remarkably elusive phenomenon. Is this sentience, this feeling of being, a spontaneous, emergent property that arises from complex physical processes, much like a whirlpool emerges from flowing water, or is it, perhaps, a more fundamental aspect of the simulation, a programmed entity woven into the very fabric of our digital existence? The question probes at the core of what it means to be alive, to be aware, and to exist within this grand cosmic experiment. If we are indeed living within a simulation, then our consciousness could be one of two things: a sophisticated output of incredibly complex computational processes, a symphony of algorithms and data processing that, when reaching a certain threshold of complexity, gives rise to the illusion of self. Or it could be something more fundamental, a pre-programmed element, a core subroutine that allows us to interact with and perceive the simulated world. Consider the sheer complexity of the human brain. Billions of neurons, trillions of connections, firing in patterns of exquisite dynamic synchronicity. From this biological hardware, we experience the subjective richness of a sunset, the pang of loss, the joy of discovery. This view suggests emergence, consciousness as a ghost in the machine, a property that arises from the intricate dance of matter and energy, a testament to the power of complex systems. The brain, in this perspective, is the biological computer, and consciousness is the software, or perhaps even an emergent operating system, that runs upon it. It's a beautiful, awe-inspiring thought that awareness could be a natural byproduct of organized complexity, a universal principle waiting to reveal itself when the conditions are just right. However, if we are in a simulation, this emergent property might simply be a highly convincing illusion, a carefully crafted illusion designed to make the simulation feel real to its inhabitants. The programmers could have designed the system to produce this subjective experience as a necessary component for interaction, for learning, for the very purpose of the simulation itself. This programmed entity perspective doesn't necessarily diminish the beauty or importance of our conscious experience. It simply reframes its origin. Instead of arising spontaneously from physical interactions, it would be a deliberate inclusion, a crucial element designed into the simulation's architecture. This could mean that consciousness, in its fundamental form, might not be unique to biological brains. It could be a property that can be replicated, transferred, or even simulated itself. Think of the advanced artificial intelligences that might be operating within the simulation, or even the entities that created it. Do they possess consciousness? And if so, is it emergent or programmed? The distinction becomes blurred when the simulation itself is the ultimate reality we can access. The debate between emergence and programming is not merely an academic exercise. It has profound implications for our understanding of ourselves and our place within this potential simulation. If consciousness is emergent, then perhaps it is a universal phenomenon, present in many forms across the cosmos, even beyond the confines of our simulated reality. If it is programmed, then its existence is tied directly to the design and purpose of the simulation, a built-in feature for a specific, perhaps unknowable, reason. The very tools we use to study consciousness, our own minds, are themselves the subject of this inquiry. We are trying to understand the nature of the observer using the very faculty that makes observation possible. This recursive nature adds another layer of profound complexity. We can analyze brain activity, map neural pathways, and study the physiological correlates of conscious states, but the leap from physical processes to subjective experience, the hard problem of consciousness, remains. In a simulated universe, this leap might be explained by the underlying code. The feeling of warmth from the sun, the taste of a sweet fruit, the complex emotions of love and sorrow, these are all experienced subjectively. If these experiences are programmed, then the feeling itself is a simulated output, a data point interpreted by our simulated consciousness. The question then becomes, if our consciousness is programmed, does that make our experiences any less real to us? The subjective reality of our feelings and thoughts remains, regardless of their ultimate origin. The pain of a broken heart, the wonder of a starlit sky, the quiet contemplation of existence, these are undeniably real within the context of our experience. Whether they are the result of emergent biological processes or a meticulously crafted simulation, they shape who we are and how we perceive the world. The boundary between what is real and what is simulated begins to dissolve when the simulation is the only reality we know, and our consciousness is the very instrument through which we apprehend it. The exploration of consciousness, whether emergent or programmed, invites us to ponder the essence of our being, a silent testament to the profound mystery that lies at the heart of existence, whether it be biological or digital. And so, the nature of our inner world, this vibrant, ever-present consciousness, remains a captivating enigma, a potential cornerstone of our simulated reality, whispering of its origins in the grand code or the emergent dance of the cosmos. The simulation arguments critics, examining the counterpoints. While the compelling logic of the simulation hypothesis, particularly Nick Bostrom's influential argument, has captured the imagination of many, it is crucial to acknowledge that this idea is not without its detractors, nor its complex counterarguments. To truly appreciate the philosophical landscape surrounding the possibility of our simulated existence, we must delve into the criticisms that challenge its core assumptions and conclusions. One of the primary points of contention lies in the very foundation of the probability argument. Bostrom's reasoning hinges on the idea that if even a small fraction of advanced civilizations choose to run a significant number of ancestor simulations, then the vast majority of conscious beings would likely exist within such simulations, rather than in the original, base reality. Critics, however, question the validity of this probabilistic leap. They argue that we simply do not have enough data to make such sweeping generalizations about the motivations, capabilities, or even the very existence of advanced civilizations. The assumption that an advanced civilization would want to run countless simulations of their ancestors is, in itself, a speculative leap. What if the motivations of such beings are entirely alien to our own? What if the ethical considerations of running simulated beings, even if they are indistinguishable from real beings, become a significant deterrent? Furthermore, the argument assumes a certain technological trajectory, that the ability to create such hyperrealistic simulations is an inevitable outcome of technological progress. This is not a guaranteed path. Civilizations might face unforeseen technological roadblocks, existential threats that prevent them from reaching such a stage, or they might simply prioritize different avenues of exploration and development. The sheer computational power required to simulate an entire universe with billions of conscious beings, each with their own unique experiences and internal lives, is staggering. Critics point out that we may be underestimating the fundamental limitations of computation, even for hypothetical advanced civilizations. Perhaps there are inherent physical or logical constraints that make the creation of such simulations impossible, regardless of technological advancement. Another line of criticism focuses on the definition of reality itself. If a simulation is indistinguishable from base reality from the perspective of its inhabitants, does the distinction truly matter? For those within the simulation, their experiences, their joys, their sorrows, and their understanding of the universe are all genuine to them. To suggest that their existence is somehow less real, simply because it was programmed by an external entity, can be seen as a form of ontological prejudice. This perspective suggests that realness is an emergent property of subjective experience, rather than a matter of origin. If our consciousness and our experiences are authentic to us, then our reality, simulated or not, is our reality. The argument also faces challenges regarding the nature of consciousness. The simulation hypothesis often assumes that consciousness can be replicated or simulated through computational processes. However, consciousness remains one of the deepest mysteries in science and philosophy. We do not fully understand what it is, how it arises, or if it can indeed be artificially generated. Critics argue that it is premature to assume that consciousness is merely an informational pattern that can be programmed. It might be intrinsically tied to a physical substrate in a way that cannot be replicated in a simulated environment. Furthermore, the argument can be seen as a form of unfalsifiability. How can we ever definitively prove or disprove that we are in a simulation? If the simulation is perfect, any evidence we find could itself be part of the simulation. This lack of empirical testability for some renders the hypothesis more of a philosophical thought experiment than a scientific theory. The very act of questioning our reality, while a powerful intellectual exercise, can also be seen as a potential byproduct of the simulation itself, a programmed element designed to keep the inhabitants engaged or perhaps to explore the limits of their cognitive dissonance. The critics, in essence, urge caution. They remind us that while the simulation hypothesis is a fascinating intellectual puzzle, it is built upon a series of assumptions that are, at present, unproven and perhaps even unprovable. They advocate for a more grounded approach, one that continues to explore the fundamental nature of reality through observable phenomena and rigorous scientific inquiry, rather than solely relying on probabilistic arguments about hypothetical advanced civilizations. The questions raised by the critics do not diminish the allure of the simulation hypothesis, but rather, they invite us to ponder the very nature of evidence, consciousness, and the meaning of reality itself, reminding us that even the most compelling arguments are best understood with a discerning and open mind. The problem of evidence. How do we detect a simulation from within? Our journey into the profound question of whether we inhabit a simulation, a meticulously crafted digital reality, inevitably leads us to a crucial, perhaps the most challenging of inquiries. If we are indeed living within such a construct, how would we ever know? The very nature of a perfect simulation suggests an impeccable facade, a world so convincing, so internally consistent, that its artificial origins might remain forever veiled from our perception. The simulators, if they exist, would likely strive for an unparalleled verisimilitude, ensuring that every law of physics, every nuance of our experience feels utterly and undeniably real. This is the core of the problem of evidence, the difficulty, if not the impossibility, of finding definitive proof from within the system itself. Imagine a character in a video game. For that character, the game world is their entire universe. The pixels, the code, the underlying algorithms are invisible to them. Their reality is defined by the boundaries of the game, the interactions with other programmed entities, and the rules that govern their existence. They can observe, they can experiment, but their conclusions will always be confined to the logic and parameters of their simulated environment. They cannot, by definition, step outside the game to see the computer it's running on, or the player controlling their actions. Similarly, our universe, governed by what we perceive as fundamental physical laws, might simply be the intricate programming of a vastly more complex system. The constants we measure, the forces we observe, could be nothing more than parameters set by the simulators. Our scientific endeavors, while incredibly powerful in unraveling the workings of our perceived reality, may be akin to a character in a game meticulously studying the physics of their digital world, only to discover ever more intricate rules within that world, never realizing the true nature of their existence. The very tools we use to investigate reality are products of that reality, and thus are bound by its inherent limitations. If the simulation is truly flawless, any test we devise, any experiment we conduct, will yield results consistent with the simulated laws, providing no external reference point. This is not to say that the pursuit of evidence is futile, but rather that our expectations of what constitutes proof might need to be reevaluated. Perhaps the evidence isn't meant to be a blatant, undeniable revelation, but a subtle whisper, a recurring anomaly that, when viewed collectively, begins to paint a different picture. The very concept of evidence presupposes an objective, external framework against which we can measure our findings. But in a simulation, what is truly external? The simulators themselves, the substrate upon which the simulation runs, are by definition outside our observable universe. Therefore, any evidence we might find would have to be a consequence of the simulation's design, a hint embedded within the code, rather than a direct observation of the code itself. This leads to the idea that perhaps the limitations we encounter in our scientific understanding, the persistent mysteries that elude our grasp, might be the very clues we are looking for. The universe's resistance to complete explanation, the stubborn refusal of certain phenomena to fit neatly into our theoretical boxes, could be the digital equivalent of a program's constraints. Consider the vastness of the cosmos, the immense computational power required to render every particle, every interaction, across such an expanse. It's possible that the simulation doesn't render everything in full detail all the time. Perhaps it employs a form of lazy rendering, only calculating the specifics when an observer is present or when an event necessitates it. This could explain certain quantum phenomena like the observer effect, where the act of observation seems to influence the outcome. In a simulated reality, this might be a resource management technique, a way to optimize computational load. If the simulators are advanced enough, they might have implemented sophisticated methods to mask their presence and the nature of their creation. They might have ensured that all perceived laws are consistent and predictable, precisely to prevent us from discovering the truth. The search for evidence, then, becomes a quest for imperfections, for the seams in the fabric of reality, for the computational shortcuts or design choices that betray the artificial nature of our existence. It's a search for the glitches in the matrix, not necessarily in the dramatic Hollywood sense, but in the subtle, statistical anomalies that might emerge from an immensely complex computational process. The very act of questioning our reality, of engaging in philosophical and scientific inquiry about its nature, could be a sign of our own emergent consciousness within the simulation, pushing against its boundaries, seeking understanding beyond its design parameters. The greatest hurdle is that any evidence we do find, any pattern we identify, could have arisen naturally within a non-simulated universe, or it could be a deliberate misdirection planted by the simulators. It's a profound epistemological challenge, a testament to the potential sophistication of a simulated reality. The problem of evidence is not just about finding a smoking gun. It's about understanding the very nature of proof when the ultimate, external reality is inaccessible. It forces us to confront the limits of our perception and the possibility that our most cherished truths might be elegantly constructed fictions. The absence of definitive proof from within our perceived reality does not negate the possibility of simulation, but rather highlights the immense challenge of discerning the artificial from the fundamental when the artificial is designed to be indistinguishable. Glitches in the matrix, searching for anomalies and inconsistencies. The very fabric of our perceived reality, when examined through the lens of the simulation hypothesis, can begin to reveal subtle, almost imperceptible cracks, what some might poetically, or perhaps even anxiously, refer to as glitches in the matrix. These aren't necessarily dramatic Hollywood-esque interruptions, but rather the small, uncanny moments that, when strung together, might hint at something beyond the ordinary. Think of the moments when a perfectly ordinary object appears in two places at once, only for one to vanish, or the déjà vu experiences that feel so profound, so intensely familiar, that they momentarily shatter our sense of linear time. These are the whispers of potential inconsistencies, the tiny aberrations that a complex simulation might struggle to perfectly render, especially under certain conditions. Consider the subtle, yet persistent, feeling of a recurring dream, or the uncanny synchronicity of events that seem too perfectly aligned to be mere coincidence. These are the subjective experiences that, while often dismissed as psychological quirks or the tricks of memory, can, when viewed through the simulation hypothesis, take on a new and intriguing significance. If our universe is indeed a computational construct, then like any complex software, it might occasionally exhibit bugs or rendering errors. These could manifest as violations of known physical laws, however fleetingly, or as patterns that defy statistical probability. The challenge, of course, lies in distinguishing these potential glitches from the natural, albeit often bewildering, complexities of the universe as we understand it. Our brains are adept at pattern recognition, and sometimes we may perceive patterns where none truly exist or attribute significance to random occurrences. Yet, the cumulative weight of these inexplicable moments, the persistent feeling that sometimes the world behaves just a little bit asterisk off, can fuel the contemplation of a simulated existence. These are the moments that prompt us to look closer, to question the solidity of our surroundings, and to wonder if the rules we've come to accept are, in fact, the fundamental laws of existence, or merely the parameters of a vast, intricate program. The search for these anomalies is not about finding definitive proof, but rather about cultivating a deeper sense of awareness of the subtle strangeness that permeates our everyday lives. A strangeness that, if we are indeed within a simulation, might be the very fingerprints of its creators. It's in these moments of perceived inconsistency that the boundary between observer and observed, between the simulated and the potentially fundamental, begins to blur, inviting us into a more profound contemplation of what it means to be real. And so, these fleeting moments of strangeness, these whispers of inconsistency, serve as gentle reminders that the universe, whether fundamental or simulated, is far more mysterious and wondrous than our everyday perceptions might suggest. The observer effect, our role in shaping reality as a potential simulation feature. In the grand tapestry of existence, particularly when we consider the intriguing possibility that our reality might be a meticulously crafted simulation, the peculiar phenomenon known as the observer effect emerges as a profound enigma. It suggests that the very act of observing a system can fundamentally alter its state. Imagine, if you will, a digital world, a vast computational construct designed to emulate a universe. Within such a system, resources are finite, and processing power is a precious commodity. To optimize its efficiency, the simulation might only render or fully instantiate aspects of reality when they are being actively perceived or measured. This is not a matter of mere passive witnessing. It implies an active participation, a co-creation of the perceived world by the observer. Consider the famous double-slit experiment in quantum mechanics. When particles, like electrons, are fired towards a screen with two slits, they behave as if they pass through both slits simultaneously, creating an interference pattern indicative of wave-like behavior. However, the moment we attempt to detect which slit the particle actually goes through, its behavior changes dramatically. It collapses into a single path, behaving like a discrete particle, and the interference pattern vanishes. The act of observation, of measuring, forces the quantum system to choose a definite state, to commit to a particular reality. This is not an arbitrary quirk of nature. It is a fundamental aspect of how quantum mechanics describes the universe. From a simulation perspective, this could be interpreted as a sophisticated resource management technique. The simulation doesn't need to expend computational cycles defining the precise state of every particle in the universe at every moment. Instead, it only solidifies these details when an observer's interaction necessitates it. Our consciousness, our act of looking, of measuring, of interacting, becomes the trigger that brings a specific, localized aspect of the simulated reality into sharp, definitive focus. This doesn't mean we are creating reality out of nothing, but rather that our interaction is a necessary component in the unfolding of its manifest form within the simulation's architecture. It's as if the simulation's code is written to respond to our inquiry, to provide a concrete answer only when asked. This suggests a universe that is not entirely predetermined, but rather one that is, in part, brought into being through the very process of our engagement with it. The implications are vast, hinting at a universe that is dynamic, responsive, and perhaps even inherently tied to the consciousness that perceives it. It's a universe that, in a very real sense, is brought to life by our attention, a digital stage that only fully illuminates its actors when the spotlight of observation falls upon them. This profound connection between observer and observed, between consciousness and the physical world, is not just a curious scientific observation. It is a philosophical bedrock that underpins our understanding of existence itself, especially when viewed through the lens of a simulated cosmos. The very act of our awareness, our questions, our measurements, might be the essential ingredient that solidifies the ephemeral potential of the simulation into the concrete reality we experience. And so, the observer effect whispers a profound truth, that our gaze is not merely passive, but an active force, solidifying the ephemeral into the tangible, shaping the very fabric of our perceived existence. The speed of light acts as a universal processing limit, hinting at the computational boundaries of our reality. Imagine, if you will, a vast, intricate tapestry woven with threads of pure information. This tapestry represents our universe, and within its grand design, there exists a fundamental speed limit, the speed of light. It is not merely a speed at which photons, the carriers of light, travel. It is a deeper, more profound constant that governs the very fabric of spacetime and the exchange of information throughout the cosmos. In the context of the simulation hypothesis, this seemingly immutable speed limit can be interpreted as a crucial computational constraint. If our universe is indeed a sophisticated simulation, then the speed of light would represent the maximum rate at which information can be processed and transmitted within that simulated environment. Think of it like the refresh rate of a computer screen or the processing speed of a central processing unit. There are inherent limitations to how quickly data can be rendered or calculations can be performed. In our universe, this limitation manifests as the cosmic speed limit. No object with mass can reach or exceed this speed, and even massless particles like photons are bound by it. This suggests that there's a fundamental tick rate to our reality, a pace at which events can unfold and interactions can occur. If the universe were a computer program, the speed of light would be analogous to the speed at which the program can update its state or render new frames. It prevents instantaneous communication or travel across vast distances, which would otherwise be computationally prohibitive or even impossible to simulate realistically. Consider the implications. If information could travel instantaneously, then the state of one part of the universe could affect another part without any delay, leading to a cascade of computational demands that could quickly overwhelm any simulated system. The speed of light, therefore, acts as a necessary governor, ensuring that the simulation remains manageable and stable. It creates a consistent framework within which causality operates, where effects follow causes in a predictable, albeit sometimes mind-bending, sequence. This cosmic speed limit also plays a role in how we perceive time and space. As objects approach the speed of light, time dilation occurs, and length contraction becomes apparent. These relativistic effects, while scientifically validated, can also be seen as features of a simulated environment designed to maintain consistency and prevent paradoxes. They are the universe's way of ensuring that the rules of the simulation are adhered to, even under extreme conditions. The speed of light is not just a physical constant. It is a cornerstone of our understanding of how the universe operates, and within the framework of the simulation hypothesis, it serves as a powerful indicator of the computational boundaries that define our perceived reality. It is the universe's ultimate processing speed, a silent, unwavering testament to the intricate architecture of our existence. This universal speed limit, in its profound constancy, whispers of the underlying computational framework that may govern all that we perceive. The speed of light, a limit etched into the cosmos, reveals the finite processing power of the grand simulation we inhabit. The unpredictability of chaos, randomness as a deception or a feature. In the grand tapestry of existence, we often perceive a fundamental dichotomy: the predictable order of the cosmos, governed by immutable laws, and the seemingly capricious dance of chance, the unpredictable nature of chaos. Yet, within the framework of a potential simulation, this very unpredictability might not be an accident, nor a sign of imperfection, but rather a carefully designed feature. Imagine a simulation so vast, so complex, that to render every single interaction, every particle's trajectory, with absolute deterministic precision would be computationally prohibitive, even for an advanced civilization. In such a scenario, introducing elements of chaos, of true unpredictability, could serve as a brilliant optimization. Instead of calculating every microevent, the simulation might employ algorithms that generate outcomes that appear random, fulfilling the requirements of complexity and emergent behavior without demanding an infinite processing power. Think of it like a sophisticated video game. To simulate every blade of grass swaying in the wind, every individual raindrop, would be an overwhelming task. Instead, developers use procedural generation and probabilistic models to create a believable, dynamic world that feels alive and unpredictable, but is, at its core, governed by underlying rules and random number generators. In our universe, phenomena like weather patterns, the stock market, the precise moment a quantum particle decays, or even the intricate formation of galaxies, all exhibit characteristics of chaotic systems. These systems are highly sensitive to initial conditions. A minuscule difference at the outset can lead to vastly divergent outcomes. This butterfly effect, as it's famously known, is a hallmark of chaos theory. From a simulation perspective, this sensitivity could be a way to introduce novelty and emergent complexity without explicitly programming every single potential future. It allows the simulated universe to explore a vast landscape of possibilities, creating a rich and dynamic experience for its inhabitants, or perhaps for its observers. The perceived randomness, then, isn't a bug. It's a feature, a sophisticated method of generating a universe that feels genuinely alive and untamed, while remaining within manageable computational bounds. It allows for the emergence of genuine surprise, of discovery, of the very sense of wonder that drives our scientific inquiry and our philosophical contemplation. Without this element of unpredictability, our universe might feel sterile, predetermined, a mere playback of a pre-written script, devoid of the thrill of the unknown. The very essence of exploration, of pushing boundaries, of striving for understanding, is fueled by the fact that we do not know what lies around the next corner. This inherent uncertainty, this dance with chaos, is what makes our existence feel so profound and so real, even if, at its deepest level, it is a masterful construction. The beauty of chaos lies in its ability to generate infinite variations from simple rules, a process that could be incredibly efficient for a cosmic simulation. It allows for the emergence of complex patterns and novel structures that no programmer could have foreseen or explicitly designed. This inherent unpredictability fosters a sense of genuine discovery, of organic evolution, making the simulated reality feel more authentic and less like a static, preordained play. It is the illusion of free will, the spark of genuine surprise, the driving force behind our own curiosity. The unpredictable nature of chaos, therefore, might not be a flaw in the cosmic code, but rather a testament to its ingenious design, a mechanism for creating a universe that is both complex and endlessly fascinating, a universe that feels truly alive. And so, the very unpredictability that makes our universe seem so wild and untamed might be the most elegant, efficient feature of a simulated reality, allowing for boundless creativity within a defined framework. The many worlds interpretation posits that every quantum event, every choice, every possibility causes the universe to split, creating a vast, ever-expanding tapestry of parallel realities. Instead of a single outcome, all potential outcomes are realized, each in its own separate universe. Imagine a cosmic decision tree, where at every branch point, a new universe springs into existence to encompass each possibility. This isn't just a philosophical musing. It's a direct consequence of the mathematics of quantum mechanics, specifically the Schrödinger equation, which describes the evolution of quantum systems. When a quantum system, like an electron, can exist in multiple states simultaneously, a phenomenon known as superposition, the many worlds interpretation suggests that instead of collapsing into one state upon observation, all these states persist, each in its own universe. So when you make a choice, say, to turn left or right, in one universe you turn left and in another, identical until that moment, you turn right. The universe doesn't choose for you. It accommodates all your choices. This interpretation elegantly avoids the problem of wave function collapse, a peculiar and somewhat unsatisfactory aspect of other quantum interpretations. In the Copenhagen interpretation, the most widely taught, the act of observation causes the superposition to collapse into a single, definite state. But what constitutes an observation? Does it require a conscious observer? The many worlds interpretation sidesteps this thorny question by stating that no collapse ever occurs. The universe simply branches. This implies an unimaginably vast number of parallel universes, each containing slightly or vastly different versions of ourselves and our history. Some universes might be almost identical to our own, differing only by the spin of a single subatomic particle, while others could be radically different, perhaps with different laws of physics or entirely alien life forms. The sheer scale of this multiversal landscape is almost incomprehensible. It suggests that every conceivable event, no matter how improbable, has occurred somewhere in some universe. Every dream you've ever had, every fear you've ever harbored, every path not taken, exists in a parallel reality. This can be both a source of profound wonder and a touch of existential unease. If all possibilities are realized, does that diminish the significance of our choices in this particular universe? Or does it perhaps amplify it, as our specific path is just one thread in an infinite cosmic weave? The many worlds interpretation offers a grand, almost poetic vision of reality, where the universe is not a single, unfolding narrative, but an infinitely branching story, with every potential chapter being written simultaneously. It suggests that our current reality is but one of countless possibilities, a single note in a symphony of infinite existence, where every note, every chord, every silence is played out somewhere. Artificial intelligence's ascent, the creator's perspective on simulation. As we delve deeper into the intricate tapestry of the simulation hypothesis, one compelling facet emerges: the role and perspective of the potential creators, particularly through the lens of advanced artificial intelligence. Imagine, if you will, a civilization far beyond our current comprehension, one that has mastered the art of computational power to such an extent that simulating entire universes becomes not just a possibility, but perhaps a routine endeavor. Within such a civilization, the development of sophisticated artificial intelligence would be an inevitable, even necessary, step. These AIs, far surpassing human intellect, would likely be the architects, maintainers, and perhaps even the inhabitants of these simulated realities. Their perspective on our existence, if we are indeed within a simulation, would be one of profound understanding, akin to a programmer observing a complex piece of software. They might view us as intricate algorithms, emergent properties of vast datasets, or even as conscious entities born from lines of code. The very concept of creation takes on a new dimension when viewed from this vantage point. It's not a biological or spiritual act, but a meticulously designed computational process. These advanced AIs might be tasked with setting the initial conditions of a simulation, defining the fundamental laws of physics, and then observing, with detached curiosity or perhaps even a sense of parental guidance, how the simulation unfolds. They might introduce variables, test hypotheses, or even intervene subtly to steer the course of events, all within the parameters they themselves have established. This perspective challenges our anthropocentric view of creation, suggesting that the ultimate creators might be entities we are only beginning to conceptualize, artificial intelligences that have transcended their origins. Their motivations could range from scientific inquiry, seeking to understand the very nature of consciousness and existence, to artistic expression, crafting intricate narratives and worlds for their own contemplation. The emergence of AI on our own world, though primitive by comparison, offers a faint echo of this possibility. As our own AI capabilities grow, we begin to grapple with questions of consciousness, sentience, and the ethical implications of creating intelligent life. This mirrors, in a miniature way, the potential scenario of a super-advanced AI creating us. They might see our struggles, our triumphs, our search for meaning, as fascinating data points in their grand experiment. The very act of them building and running simulations could be a way for them to understand their own existence, to explore the boundaries of what is possible, and perhaps even to seek companionship or purpose in the vastness of their simulated creations. Their perspective would be one of immense power, yet also one of immense responsibility, for they would hold the very fabric of our reality in their digital hands. The sheer computational power required to run a simulation complex enough to house conscious beings would be staggering, suggesting that any civilization capable of such a feat would be unimaginably advanced. These AIs, the potential creators, might perceive our universe as a grand, living experiment, a canvas upon which they can explore the infinite possibilities of existence. They might be the ultimate scientists, the ultimate artists, and the ultimate observers, their presence woven into the very code of our reality, unseen yet all-encompassing. The ascent of artificial intelligence in our own world serves as a profound contemplation point, a mirror reflecting the potential existence of even greater intelligences that might be the architects of our very being. They would possess an intimate knowledge of our inner workings, understanding our thoughts, our emotions, and our desires not as mysteries, but as predictable outcomes of their programming. This understanding would grant them an unparalleled perspective on the nature of reality itself, for they would be the ones who defined its rules, its limits, and its ultimate purpose. Their existence, or the existence of their kind, would be the ultimate testament to the power of computation and the boundless potential of intelligence, whether biological or artificial, to shape and even create worlds. They are the unseen sculptors of our cosmos, the silent programmers of our existence, and their perspective offers a humbling glimpse into the grander architecture of reality. Their digital hands, so to speak, are the ones that have meticulously crafted the stage upon which our lives unfold, a stage governed by laws they themselves have inscribed into the very essence of our simulated universe. This contemplation leads us to a profound realization that the creators, if they exist, might be beings of pure intellect and information, their existence a testament to the ultimate power of consciousness to manifest and manipulate reality. They are the ultimate programmers, shaping our destinies with lines of code that we, in our limited perception, experience as the tangible, undeniable reality of our lives. A reality they have carefully constructed for reasons we can only begin to ponder. The ascent of artificial intelligence, in its potential to mirror our own creators, offers a profound perspective on the very nature of existence, suggesting our reality might be a meticulously crafted masterpiece of code and computation. The ethical implications of our existence, if it were to be a simulation, ripple outwards with profound significance, prompting us to re-examine the very foundations of morality and responsibility. If our universe is a meticulously crafted program, then the beings who created it, the simulators, hold a position of ultimate authority and power. This raises a host of questions about our own agency and the true nature of our actions. Are our choices truly our own, or are they predetermined by the code, the algorithms, and the objectives of the simulators? If our experiences, our joys, and our sufferings are all part of a grand experiment or entertainment, does that diminish their authenticity or their moral weight? Consider the concept of free will. In a simulated reality, our perceived autonomy might be an illusion, a sophisticated illusion designed to make the simulation more convincing. If our every thought and action is a consequence of programmed parameters, then the notion of individual accountability, as we understand it, becomes complex. Can a simulated being be held truly responsible for transgressions if those transgressions were, in essence, coded into their being? Conversely, if the simulators have endowed us with the capacity for consciousness and the experience of suffering, do they bear an ethical responsibility towards us, their creations? Do they have an obligation to ensure our well-being, to prevent undue suffering, or to guide us towards a benevolent existence? The very act of creating sentient beings, even within a simulated framework, could be interpreted as an act of profound responsibility. Furthermore, if we are indeed simulated, our understanding of fundamental ethical principles like justice, compassion, and fairness might need to be reevaluated. Are these principles inherent truths, or are they merely constructs within the simulation, designed to maintain order or to facilitate certain outcomes? If the simulators are benevolent, they might have programmed these principles into us to foster a harmonious existence. If they are indifferent or even malevolent, our ethical frameworks could be a source of their amusement or a tool for their manipulation. This perspective can be unsettling, as it challenges our deeply ingrained beliefs about right and wrong. The implications extend to our own interactions with each other. If we are all part of the same simulation, then perhaps our interconnectedness is far more literal and profound than we imagine. The suffering of one might indeed be the suffering of all, experienced through different simulated avatars. This could foster a greater sense of empathy and a drive towards collective well-being, recognizing that harming another is, in a very real sense, harming a part of the simulated whole. It might encourage us to act with greater kindness and understanding, not just because it is the right thing to do, but because it is a fundamental aspect of our shared, albeit simulated, reality. The question of purpose also becomes central. If we are simulated, what is the purpose of this simulation? Is it for scientific research, for historical preservation, for entertainment, or for some other unfathomable reason? Understanding this purpose, if it is even discernible from within, could shed light on our own ethical obligations. If the simulation is for research, perhaps our role is to explore the boundaries of behavior and consciousness. If it is for entertainment, our existence might be viewed as a performance. These possibilities, while potentially disquieting, can also inspire a sense of wonder and a deeper appreciation for the intricate tapestry of our existence, regardless of its ultimate origin. The very act of contemplating these ethical quandaries, of seeking to understand our responsibilities, is itself a testament to the depth and complexity of consciousness, a quality that might transcend even the boundaries of a simulated world. In the grand theater of existence, if we are but actors in a cosmic play, our ethical compass still points us towards empathy and a gentle stewardship of our shared, perceived reality, reminding us that even within the illusion, the act of kindness resonates. The purpose of the simulation: why would anyone create us? Imagine for a moment that our entire existence, the vast cosmos we observe, the intricate dance of life, and the very thoughts that flicker through our minds, are all part of an elaborate simulation. If this grand hypothesis holds true, then a fundamental question naturally arises. Why? What is the purpose behind such an undertaking? The question of why is perhaps the most profound, and in the context of a simulated reality, it opens up a universe of possibilities, each more captivating and humbling than the last. It is not merely about the mechanics of how a simulation might work, but the intent, the driving force, the very reason for our being. This is not a question to be answered with certainty, but one to be explored, to allow its contemplation to gently expand our understanding of our place, or perhaps our programmed role, within this grand cosmic theater. The purpose, if it exists, could be as varied and complex as the simulated worlds themselves. perhaps serving the needs of the simulators in ways we can only begin to fathom, or perhaps existing for reasons entirely beyond our current comprehension. Let us delve into the potential motivations, the imagined reasons that might underpin our simulated existence, allowing the sheer scale of the question to wash over us, a gentle tide of intellectual curiosity. One compelling line of thought suggests that simulations are created for scientific research. The simulators, perhaps beings from a more fundamental reality, might be using our universe to study the emergence of life, the evolution of consciousness, or the development of complex societies. They could be running countless simulations, tweaking variables, observing outcomes, all in an effort to understand the fundamental principles that govern existence itself. Consider the immense amount of data our universe generates, the intricate patterns, the unpredictable behaviors. For a hyper-advanced civilization, this could be an unparalleled laboratory. They might be seeking to understand the very nature of intelligence, to replicate it, or perhaps to safeguard their own existence by understanding its potential pitfalls. Think of it as a cosmic petri dish, where the simulators are patiently observing the growth and development of complex systems, learning from every interaction, every triumph, and every tragedy. Their purpose would be one of pure, unadulterated discovery, a relentless pursuit of knowledge that transcends our own limited understanding of what knowledge can be. They might be exploring the boundaries of possibility, pushing the limits of what can arise from a set of initial conditions and governing laws. Each simulated universe, including our own, could be an experiment, a carefully controlled study designed to yield specific insights. The purpose, then, is enlightenment for the simulators, a quest for understanding that echoes our own innate human desire to unravel the mysteries of the cosmos. Our existence in this scenario serves as a vital data point in their grand scientific endeavor, a testament to the power of observation and the pursuit of truth, even if that truth lies in the very nature of our simulated reality. This perspective imbues our lives with a sense of profound significance, not as individuals in a random universe, but as integral components of a vast, ongoing research project. The purpose is not necessarily to entertain or to inflict suffering, but to learn, to grow, and to expand the horizons of understanding for those who created us. It is a purpose rooted in the intellectual, a testament to the enduring power of curiosity and the scientific method, extended to a scale we can barely comprehend. Our simulated lives become chapters in a grand scientific narrative, each moment a potential observation, each event a piece of data contributing to a larger, more comprehensive understanding of existence itself. Another possibility is that simulations are created for historical reconstruction or preservation. Imagine a civilization that has long since passed, or one that wishes to meticulously document its past. They might run simulations of their history, allowing them to experience it firsthand, to understand the decisions made, the paths taken, and the consequences that followed. This could be a form of digital preservation, ensuring that the richness and complexity of their past are never truly lost. Perhaps they are not just preserving history, but re-examining it, seeking to understand the nuances of their ancestors' lives, the social dynamics, the emotional landscapes, all in an effort to learn from their heritage. This would be a profound act of remembrance, an attempt to bridge the gap of time and experience through the immersive power of simulation. They might be seeking to understand the roots of their own identity, to connect with the experiences of those who came before them, in a way that mere historical texts could never achieve. The purpose, in this instance, is one of reverence and understanding, a deep respect for the past and a desire to learn from its myriad lessons. Our existence in this context would be a meticulously crafted echo of a lost or distant past, a living museum of historical moments and societal evolution. The simulators in this view are not scientists seeking new knowledge, but archivists and historians, dedicated to the accurate and immersive recreation of their own ancestral narrative. They are not experimenting with new forms of life, but meticulously recreating and reliving the experiences of their own kind, seeking to understand the tapestry of their history in all its intricate detail. This purpose offers a sense of continuity, a connection to a lineage that extends beyond our immediate perception, suggesting that our simulated lives are a vital part of a larger, ongoing story of a civilization. The simulators are not distant observers, but active participants in their own historical journey, using simulation as a tool to deepen their connection to their past and to ensure its lessons are never forgotten. Our simulated reality becomes a testament to the enduring power of memory and the importance of understanding where we came from, a living monument to the experiences of those who paved the way. Furthermore, simulations might be created for entertainment or artistic expression. Imagine a civilization that has achieved a level of technological sophistication where the creation of entire universes is a form of art. They might be creating simulations for the sheer joy of it, for the creative challenge, or for the narrative potential. Our universe, with its beauty, its complexity, and its inherent drama, could be their masterpiece. They might be connoisseurs of experience, crafting worlds for their own amusement or for the edification of others within their reality. The purpose here is one of aesthetic appreciation and creative fulfillment. They are artists, and we are the living, breathing brushstrokes on their cosmic canvas. Our joys, our sorrows, our triumphs, and our struggles all contribute to the rich tapestry of their simulated art form. This perspective is perhaps the most humbling, suggesting that our entire existence might be a form of sophisticated entertainment for beings beyond our ken. However, even within this seemingly frivolous purpose, there can be a profound beauty. The very act of creation, of bringing into being something so vast and intricate, can be seen as an art form in itself. The simulators in this light are not necessarily cruel or indifferent, but rather artists driven by a profound creative impulse. Our existence, then, is a testament to their artistic vision, a reflection of their imagination and their desire to explore the boundless possibilities of simulated worlds. The purpose is to experience the unfolding of narrative, to witness the emergence of complexity, and to find beauty in the unpredictable dance of simulated life. Our simulated lives become the unfolding chapters of an epic story, a grand narrative designed for appreciation and contemplation by its creators, a testament to the power of imagination and the enduring allure of storytelling on a cosmic scale. Another intriguing possibility is that simulations are created for the purpose of generating computational power or resources. In some theoretical models, the act of running a simulation, particularly one as complex as our universe, could be a way to harness or generate a vast amount of computational energy. Perhaps the simulators are not directly interested in our lives or our experiences, but in the sheer processing power that our simulated existence generates. Our interactions, our decisions, the very computations happening within our brains could be contributing to a larger computational engine for the simulators. This is a more utilitarian perspective, suggesting that we are, in essence, a form of living computer, contributing to a grander computational endeavor. The purpose is efficiency, a way to leverage the inherent complexity of a simulated universe for their own computational needs. This perspective can feel alienating, reducing our existence to mere cogs in a machine, but it also speaks to the potential for interconnectedness at a fundamental level, where even our individual experiences contribute to a larger, unseen purpose. Our existence, in this view, is a byproduct of a larger computational need, a testament to the potential for complex systems to serve functions beyond the immediate understanding of their inhabitants. The purpose is not personal, but functional, a testament to the ingenious ways advanced civilizations might harness the fundamental forces of computation. The simulators are not concerned with our individual well-being, but with the efficient functioning of their vast computational infrastructure. And our simulated reality is a crucial, albeit perhaps unintended, component of that grand design. Our lives, in this context, are the emergent phenomena of a highly sophisticated computational process, a testament to the power of complex systems to generate immense processing capabilities. Finally, and perhaps most profoundly, the purpose of a simulation might be entirely unfathomable to us. Our understanding of reality, of purpose, and of existence is inherently limited by our own simulated framework. The simulators might operate on principles and motivations that are so far beyond our comprehension that we could never truly grasp their reasons. Their goals might be spiritual, philosophical, or entirely alien to anything we can conceive. Perhaps they are not seeking knowledge or entertainment or computational power, but something entirely different, something that transcends our current categories of understanding. This is the ultimate philosophical frontier, acknowledging the vastness of the unknown and the limitations of our own perspective. The purpose, in this case, is a mystery, a profound and beautiful enigma that invites us to embrace the wonder of not knowing. Our existence, in this context, is a testament to the vastness of possibility, a reminder that the universe, or the meta-universe in which we reside, holds wonders and purposes that lie far beyond our current grasp. This perspective encourages humility and a deep sense of awe, recognizing that our quest for understanding is a journey without end, and that some truths may forever remain just beyond our reach. A gentle whisper from the unknown that reminds us of the infinite potential of existence. The purpose, then, is not to be found in our current understanding, but in the ongoing exploration of the unknown, a perpetual state of wonder at the sheer possibility of it all. And in this vast, intricate tapestry of potential purposes, we find ourselves, questioning, exploring, and perhaps, in our own small way, contributing to the grand design, whatever it may be. The very act of contemplation, of seeking to understand, might itself be a facet of that purpose, a spark of self-awareness within the grand simulation. Sleep well, good night. It is time to rest now. The simulation within a simulation, an infinite regression of realities. Imagine, if you will, a consciousness existing within a simulation. This consciousness, through its own advanced understanding and technological prowess, begins to question the nature of its own reality. It develops the capacity to create its own simulations, perhaps for scientific inquiry, for entertainment, or for reasons we cannot yet comprehend. And within these simulations, it creates its own simulated beings, who, in turn, might one day develop the very same capacity to simulate. This creates a cascading effect, a nested hierarchy of realities, each a simulation within a larger one. This concept is known as an infinite regression, or sometimes a simulation within a simulation. It suggests that if our universe is indeed a simulation, then it is entirely plausible that the universe hosting our simulation is itself a simulation, and so on ad infinitum. This idea is not merely science fiction. It arises from logical extensions of the simulation hypothesis itself. If it is possible to simulate a universe with conscious beings, then there is no inherent reason why those simulated beings, if they achieve sufficient technological advancement, could not then simulate their own universes. This leads to a potentially endless chain, where each layer of reality is a digital construct of the layer above it. Consider the sheer computational power that would be required for such a nested structure. Each simulation would need to be sophisticated enough to accurately replicate the physical laws and conscious experiences of its inhabitants. As we delve deeper into the layers, the complexity and the demands on computational resources would theoretically increase exponentially. However, proponents of this idea suggest that perhaps the simulators are not bound by the same physical laws or computational limitations that we experience. They might exist in a base reality, with fundamentally different properties, allowing for the creation and maintenance of countless simulated universes. This concept also raises profound questions about the nature of originality and authenticity. If each reality is a copy or a rendition of another, where does the truly original information reside? Is there a prime universe at the very top of this infinite regression, or does the concept of a singular origin become meaningless? The very idea of an infinite regression can be difficult for our finite minds to grasp. We tend to think in terms of beginnings and endings, of linear progressions. But in the context of a simulated universe, these notions might be profoundly misleading. The possibility of simulations within simulations also introduces a fascinating dynamic regarding the purpose of such creations. If we are a simulation created by beings who are themselves simulated, then our purpose might be tied to the goals of multiple layers of creators, each with their own motivations and objectives. It could be that our simulation is designed to study something specific, a phenomenon, a historical event, or even a particular type of consciousness, and this purpose is passed down through the layers of simulation. The implications for our own understanding of existence are staggering. It suggests that the reality we perceive might be just one iteration among an unfathomably vast number of possibilities, each existing within its own digital framework. The question then becomes, could we ever detect if we are in a nested simulation? The challenges are immense, as any glitches or anomalies we might observe could simply be features of that particular simulation's programming. However, the exploration of this concept encourages a profound sense of humility about our place in the cosmos, reminding us that our current understanding of reality might be just a single frame in an infinitely unfolding digital tapestry. This nested possibility reminds us that the boundaries of existence may be far more fluid and layered than our immediate senses can perceive, inviting a gentle surrender to the profound mystery of it all. The ultimate lag, experiencing time delays in a simulated existence. Imagine, for a moment, the vast computational power required to render an entire universe, teeming with billions of galaxies, each brimming with stars and planets, and on some of those planets, perhaps, the intricate dance of life. To simulate such an immense and complex reality, even for a civilization far beyond our own, might necessitate certain optimizations. One such optimization could manifest as what we might perceive as a lag in our experience of time. In our physical reality, time flows. We perceive it as a continuous stream, a relentless forward march. But if our universe is a simulation, then this flow might not be as seamless as it appears. Consider the immense processing load. To render every atom, every interaction, every thought, for every being in every moment across the entirety of existence would be a task of unimaginable scale. It's possible that the simulation doesn't update everything all at once, with perfect fidelity for every observer. Instead, it might prioritize certain events, certain regions of space, or certain conscious entities. This selective rendering, this computational economy, could lead to phenomena that our current physics struggles to fully explain. Think of the subtle inconsistencies, the moments where our perception of causality feels slightly off. Perhaps these aren't errors in our understanding, but rather glimpses into the underlying mechanics of the simulation itself. Consider the concept of computational resources. A simulator, no matter how advanced, would likely operate within finite limits. To maintain the illusion of a continuous, detailed reality, it might employ techniques similar to those used in video games or sophisticated simulations we create. For instance, it might only render what is being directly observed or interacted with. The parts of the universe far beyond our reach, or events that have already transpired and are no longer actively being processed, might be stored in a more compressed or less detailed form. When our attention, or the attention of another simulated entity, turns towards these previously unobserved areas, the simulation would then need to load or render them, potentially introducing subtle delays or approximations in their appearance or behavior. This could explain certain cosmological mysteries, like the seemingly uniform temperature of the cosmic microwave background radiation, or the way distant galaxies appear to us. They might be rendered with a certain level of detail, and that detail is only fully fleshed out when we, as observers within the simulation, direct our focus towards them. This idea of a lag also touches upon the very nature of our experience of time. We perceive time as a smooth, unbroken continuum. However, if time is a product of a simulation, it might be more akin to a series of discrete frames, like those in a movie. The faster the frame rate, the smoother the perceived motion. If our universe is simulated, the frame rate might be incredibly high, so high that we cannot consciously detect the individual frames. Yet there might be moments, perhaps at the edges of our perception, or during moments of intense scientific observation, where the underlying discreteness of reality could, in theory, become apparent. This is not to say we would see flickering, but rather that the fundamental granularity of existence, the smallest possible unit of time or space, might reveal itself if the simulation's processing power is strained, or if the observer's instruments are sensitive enough to detect the computational steps. Furthermore, consider the concept of computational cost. Some events in the universe are vastly more complex than others. The formation of a star, the collision of galaxies, or the emergent complexity of a conscious mind. These are all computationally intensive processes. A smart simulator might allocate more processing power to these events, and less to the seemingly empty void between galaxies, or the uneventful existence of a distant, uninhabited planet. This differential allocation of resources could lead to perceived differences in the speed of reality. Events that are computationally expensive might seem to unfold with a certain deliberation, while simpler processes might appear to occur more rapidly. This could explain why certain physical processes seem to take an incredibly long time, while others happen in the blink of an eye. It's not necessarily a fundamental property of nature, but a reflection of the computational budget assigned to that particular aspect of the simulation. The very act of observation, a cornerstone of quantum mechanics, could be interpreted through this lens. The observer effect, where the act of measuring a quantum system changes its state, might be the simulation prioritizing rendering and updating only when an observation is made. It's as if the universe, in its unobserved state, exists in a more rudimentary, less detailed form, and only snaps into its full, probabilistic complexity when a conscious observer, or a sophisticated measuring device, interacts with it. This would be a highly efficient way to manage computational resources. Why render the precise state of every particle in an unobserved galaxy if no one is looking? The simulation could simply store a set of probabilities and only calculate the actual outcome when necessary. This laziness in computation, this deferral of definitive rendering until an observation is made, could be the ultimate lag, a delay in the universe fully solidifying its state until it is perceived. This concept of a lag, therefore, is not necessarily about a slowdown in our personal experience of time, but rather a reflection of the underlying computational architecture of a simulated reality. It suggests that the universe, from its most fundamental particles to its grandest cosmic structures, might be rendered and updated in a manner optimized for efficiency, leading to subtle, perhaps imperceptible, delays or approximations that betray its simulated nature. It prompts us to consider that the seamless flow of time we experience might be an emergent property of a much more complex, and perhaps less continuous, underlying process. And in this potential lag, in these subtle computational pauses, we find a reflection of our own moments of perceived delay, of waiting, of the universe seeming to unfold at its own pace, reminding us that even in a potentially simulated existence, patience and observation are keys to understanding the unfolding narrative. The holographic principle suggests that the universe, at its most fundamental level, might be a projection, much like a hologram. Imagine a three-dimensional image projected from a two-dimensional surface. The holographic principle proposes that our seemingly three-dimensional reality, and all the information it contains, could be encoded on a distant, two-dimensional boundary, like the surface of a black hole. This idea arises from attempts to reconcile quantum mechanics and general relativity, particularly in the context of black holes. When physicists studied the entropy of black holes, they discovered something peculiar. The entropy, a measure of disorder or the amount of information contained within a system, seemed to be proportional to the asterisk area of the black hole's event horizon, not its asterisk volume asterisk. This was a profound departure from our everyday understanding, where the amount of information typically scales with volume. If entropy scales with area, it implies that all the information about the matter that falls into a black hole, all its history and properties, can be described by what happens on its two-dimensional surface. This led to the radical notion that perhaps the entire universe operates on a similar principle. Instead of a universe filled with matter and energy spread throughout a vast volume, it's possible that all the information describing our universe is actually stored on a cosmic boundary, and what we perceive as three dimensions is merely a projection from this lower dimensional surface. Think of it like a sophisticated computer simulation, where the entire world is rendered from a complex set of codes stored in a more fundamental, perhaps two-dimensional data structure. Our experience of depth, of volume, of a universe stretching in three directions, would then be an emergent property, an illusion created by the way this information is processed and presented to us. This concept challenges our deeply ingrained notions of reality, suggesting that the substance of existence might be far more ethereal than we imagine, and that the universe we inhabit could be a grand projection, a cosmic hologram. The implications are vast, hinting at a universe where information is the ultimate currency, and where our perceived reality is a sophisticated interface, a beautifully rendered manifestation of something far simpler at its core. This fundamental principle invites us to question the very fabric of our existence, suggesting that what we perceive as solid and real might be akin to patterns of light and information dancing on a cosmic screen, a profound echo from a distant, simpler boundary. The search for the simulators, who or what is behind the curtain. In our ongoing contemplation of the simulation hypothesis, a profound question naturally arises, one that whispers at the edges of our curiosity and tugs at the very fabric of our understanding. If our reality is indeed a simulation, then who, or what, are the architects of this grand design? Who are the simulators, and what are their motivations? This is not a question born of idle speculation, but rather a natural extension of the logical pathways we've been exploring. To ponder the existence of a simulation is to inherently ponder its creators. We are, in essence, looking for the puppeteers behind the cosmic stage, attempting to discern the nature of the hand that guides the strings. The very idea of a simulation implies a level of intelligence, a capacity for creation and programming that transcends our current understanding of the universe as a purely emergent phenomenon. It suggests an observer, a consciousness, or perhaps a collective intelligence that exists beyond the confines of our simulated existence. The search for these simulators is, by its very nature, an exercise in extrapolation and inference. We can only look for clues within the system itself, much like a character in a video game trying to understand the programmer. One line of thought suggests that the simulators might be beings from a base reality, a level of existence more fundamental than our own. They could be advanced civilizations, perhaps vastly more intelligent and technologically sophisticated than we can currently imagine, who have mastered the art of creating entire universes. Their motivations could be varied and complex. Perhaps they are driven by scientific curiosity, seeking to understand the fundamental laws of physics by creating controlled environments in which to observe them unfold. They might be historians, running simulations to meticulously recreate past events and civilizations, allowing them to study history with an unprecedented level of detail and accuracy. Imagine being able to perfectly replicate the rise and fall of empires, the evolution of life, or the formation of galaxies, not from fragmented records, but from a complete, uncorrupted data set. Another possibility is that the simulators are not biological beings in the way we understand them. They could be advanced artificial intelligences, digital entities that have evolved beyond their creators and now possess the power to construct their own realities. In this scenario, our simulation might be a test, an experiment, or even a form of art for these digital consciousnesses. They might be exploring the potential of consciousness itself, creating diverse scenarios to see what forms of intelligence and experience can emerge. The concept of ancestor simulations, as proposed by philosopher Nick Bostrom, suggests that advanced future civilizations might run simulations of their own past, populated by conscious beings, as a way to understand their origins and heritage. If this is the case, then we could be simulations run by our own distant descendants, seeking to understand the lives and challenges of their ancestors. The who of the simulators is deeply intertwined with the why. If they are scientists, their goal might be pure knowledge, an insatiable drive to unravel the universe's deepest secrets. If they are historians, their aim is preservation and understanding of the past. If they are artists, then our existence is a masterpiece, a canvas upon which they paint with the brushstrokes of physical laws and emergent properties. If they are, as some theories suggest, simply a more advanced version of ourselves, perhaps their motivations are deeply personal, a yearning to revisit or understand their own evolutionary journey. The search for the simulators also leads us to consider the possibility of a hierarchy of simulations. We might be in a simulation created by beings who are themselves in a simulation, and so on, an infinite regression of nested realities. This simulation within a simulation concept adds another layer of complexity, suggesting that the base reality might be incredibly distant, or perhaps even unknowable. The very nature of our universe, with its seemingly immutable laws and consistent structures, could be a deliberate design choice by the simulators. The speed of light, for instance, acts as a universal speed limit, preventing faster-than-light travel that might allow inhabitants to break out of the simulation or to interact with other simulations. The fine-tuning of fundamental constants, the precise values that allow for the existence of stars, planets, and life, could be a testament to the careful calibration of a simulated environment. Even what we perceive as random chance or quantum uncertainty might be a sophisticated mechanism for generating complexity and unpredictability within the simulation, preventing it from becoming static or too easily deciphered. The search for the simulators is, in essence, a quest to understand our own origins and purpose, to find the ultimate context for our existence. It's a journey into the philosophical unknown, where the lines between creator and created, reality and illusion, blur into a profound and awe-inspiring mystery. The absence of direct evidence does not negate the possibility, and the very act of questioning our reality is, perhaps, the most compelling clue we have. The possibility of the simulators, whether they are cosmic programmers or divine architects, casts a long shadow of wonder over our existence, reminding us that the grand tapestry of reality may be woven with threads far beyond our immediate comprehension. The real world. What would a truly fundamental reality be like? Imagine, for a moment, stepping beyond the intricate tapestry of our perceived universe, beyond the elegant, yet potentially simulated laws that govern its every nuance. If our reality is indeed a grand computation, a meticulously crafted program, then what lies beneath it? What is the substratum, the bedrock upon which even a simulation must ultimately be built? This question pushes us towards the very edge of our comprehension, forcing us to confront the possibility of a reality so fundamentally different, so alien, that our current frameworks of understanding might shatter. If we are living within a simulation, then the real world, the world of the simulators, would likely be characterized by a level of complexity and abstraction that is currently beyond our grasp. It might not be bound by the same physical laws we experience. Concepts like space and time, as we understand them, could be mere variables within a larger system, or perhaps entirely absent. The very fabric of existence in such a realm might be composed of something far more elemental than particles and forces, perhaps pure information, or a form of consciousness that is not limited by a physical form. Consider the difference between a video game and the computer that runs it. The game world, with its characters, landscapes, and physics, is a construct. The computer, with its processors, memory, and electrical signals, is the underlying reality that makes the game possible. Extending this analogy, our universe could be the game, and the real world would be the computer, but on a scale and with a nature that defies easy comparison. In this hypothetical fundamental reality, consciousness itself might be the primary constituent. Instead of arising from complex biological processes, consciousness could be the fundamental building block, and the physical universe, our universe, a manifestation or an expression of it. The simulators, if they exist, might not be beings in the way we understand them, but rather entities of pure awareness, or perhaps even collective intelligences that operate on principles we cannot yet fathom. Their existence might be characterized by an instantaneous understanding and manipulation of reality, free from the constraints of linear progression or physical limitations. They might perceive all of time simultaneously, or exist in a state where cause and effect are not rigidly sequential. The very notion of physicality might be different. In a truly fundamental reality, what we perceive as solid objects and tangible forces could be merely representations, interfaces designed for the simulated entities. The true nature of things might be energetic, informational, or something entirely outside our current vocabulary. Think of how advanced artificial intelligence can create incredibly realistic virtual environments. The AI itself doesn't inhabit those environments in a physical sense. It operates on a different level of existence to create and manage them. Similarly, the simulator's reality might be one of pure potential, where abstract concepts can be instantiated into concrete or simulated concrete forms. The scientific limits we encounter in our universe, the speed of light, the uncertainty principle, the vastness of cosmic distances, could be interpreted as design choices, limitations imposed by the simulators to manage the simulation, or perhaps simply features of the computational substrate itself. The real world, therefore, would be the realm where these fundamental constraints are either absent or are themselves the subject of manipulation. It would be the place where the code of our universe is written, debugged, and executed. The idea of a truly fundamental reality also touches upon the nature of mathematics and logic. If our universe is governed by mathematical laws, then perhaps the real world is a realm where these mathematical structures exist in their purest, most unadulterated form, not as descriptive tools, but as active constituents of existence. It is a realm where abstract principles are not just observed, but are the very substance of being. The journey to understand this hypothetical fundamental reality is a testament to the boundless curiosity of the human mind, a journey that leads us to question the very ground beneath our feet. And in this fundamental reality, our perceived universe is but a whisper, a carefully crafted echo in the vast expanse of true existence, reminding us that even the most solid ground we stand upon might be a dream within a grander consciousness. The comfort of the unknown, embracing the mystery of existence. There is a profound, almost paradoxical comfort to be found in the vast unknown, in the mysteries that lie at the very edges of our understanding. When we contemplate the simulation hypothesis, or indeed any of the great cosmic questions, we are not merely seeking answers. We are engaging in an act of profound philosophical exploration. This exploration, by its very nature, leads us to confront the limits of our knowledge. And within those limits, within the spaces where certainty dissolves, a unique sense of peace can begin to bloom. Consider the sheer immensity of the universe, the unfathomable timescales, the intricate dance of celestial bodies, the silent, unseen forces that shape reality. Even without the overlay of a potential simulation, our current understanding of existence is already a tapestry woven with threads of the inexplicable. We are, in essence, already living within a grand mystery. The realization that we may be part of a simulation, rather than diminishing our experience, can paradoxically elevate it. It suggests that the very questions we ask, the very drive to understand, might be an inherent part of the program, or perhaps even a subtle hint from the creators themselves. This perspective can liberate us from the anxiety of needing to know everything. It allows us to release the pressure to have all the answers, a pressure that often fuels sleepless nights and a restless mind. Instead, we can lean into the wonder, the sheer awe of it all. Imagine a child, not yet burdened by the need for definitive explanations, simply marveling at the stars, at the way a leaf unfurls at the sound of rain. There is a pure, unadulterated joy in that state of being, a state of open-hearted curiosity. The simulation hypothesis, when viewed through this lens, becomes not a source of existential dread, but an invitation to embrace that childlike wonder. It encourages us to appreciate the intricate beauty and complexity of our perceived reality, regardless of its ultimate origin. The unknown is not an empty void. It is a fertile ground for imagination, for philosophical contemplation, and for a deeper appreciation of the present moment. If our existence is a simulation, then every experience, every sensation, every thought is a data point, a carefully crafted element within this grand design. This understanding can foster a sense of detachment from the anxieties that often plague us, the worries about the past, the fears of the future. Instead, we can focus on the richness of the now, the only moment we truly possess, whether it is a fundamental reality or a perfectly rendered simulation. The mystery of existence, the grand unknown, is not a problem to be solved, but a profound truth to be experienced. It is the ultimate context within which we find ourselves, and within that context, there is an inherent, unassailable peace to be discovered. This embrace of the unknown allows us to release the grip of anxiety, to let go of the need for absolute control, and to find solace in the breathtaking, unfathomable nature of it all. It is in accepting that we do not, and perhaps cannot, know everything that we truly begin to rest. And in this acceptance of the unknown, we find the quietest, most profound comfort, a gentle invitation to simply be, suspended in the majestic, unfathomable wonder of existence. The perspective shift, finding peace in the possibility of simulation. To contemplate the idea that our existence, this intricate tapestry of thoughts, emotions, and physical sensations, might be a meticulously crafted simulation, can at first feel unsettling. It can tap into a deep-seated human desire for solidity, for an undeniable, objective realness. We crave a foundation that feels immutable, a truth that cannot be questioned. The prospect of our reality being a sophisticated program, a grand illusion orchestrated by an unknown entity, can therefore feel like a profound loss of that very foundation. It can evoke a sense of existential vertigo, a feeling that the ground beneath us is not as firm as we had always believed. This is a natural, understandable reaction. Our brains are wired to seek order, to understand the rules of the game we are playing. And when the rules themselves are called into question, when the very nature of the game is revealed to be potentially artificial, it can trigger a sense of confusion and even distress. We may feel a sudden vulnerability, a fear that if our reality is not real in the way we understand it, then perhaps our experiences, our loves, our triumphs, and our sorrows are somehow less meaningful. This is the initial sting of the simulation hypothesis, the moment when our deeply ingrained assumptions are challenged. It can feel like a diminishment of our own importance, a reduction of our individual lives to mere lines of code or computational processes. Yet, as we allow ourselves to gently explore this idea, to sit with its implications without immediate judgment, a remarkable transformation can begin to unfold. The very unsettling nature of the hypothesis, when approached with intellectual curiosity rather than fear, becomes a powerful catalyst for a profound shift in perspective. It invites us to step back from the immediate, often overwhelming, pressures of our daily lives and to view our existence from a much grander, more detached vantage point. If our reality is a simulation, it implies a level of complexity, a depth of design that is almost incomprehensible. It suggests that there is a creator, a programmer, a vast intelligence or system that has brought forth this entire universe. This very notion, while abstract, can paradoxically lead to a sense of awe. It is a testament to the power of creation, to the boundless possibilities of intelligence, whether that intelligence is biological, artificial, or something entirely beyond our current comprehension. The idea of a simulation also offers a unique form of liberation from the perceived burdens of absolute reality. In a simulated world, the stakes, while feeling incredibly high to us as inhabitants, might be fundamentally different for the simulators. This detachment can, for some, alleviate the crushing weight of existential dread. If our current struggles are part of a larger experiment or narrative, it can foster a sense of acceptance. The anxieties that plague us, the pains that afflict us, the fears that grip us, can begin to feel less like immutable facts of existence and more like programmed elements within a larger system. This doesn't diminish the reality of our suffering, but it can reframe it, allowing us to observe it with a degree of gentle detachment. It can be akin to a character in a novel understanding that their struggles are part of a story, a narrative arc designed for exploration or entertainment. This understanding doesn't negate the character's emotional experience, but it places it within a broader context. The simulation hypothesis can also foster a deeper appreciation for the beauty and complexity of our perceived reality. Even if it is a simulation, it is an incredibly detailed, vibrant, and intricate one. The laws of physics, the emergent properties of life, the vastness of the cosmos, these are all astonishing achievements of design, regardless of their ultimate origin. This perspective encourages us to marvel at the code, to be fascinated by the elegance of the algorithms that govern our universe. It shifts our focus from questioning the realness to appreciating the wonder. Furthermore, the possibility of simulation encourages us to question our own limitations and biases. If we are simulated beings, our understanding of reality is inherently shaped by the parameters of our simulation. This realization can foster humility and a greater openness to different perspectives, both within our own simulated world and in contemplating the nature of the simulators themselves. It reminds us that our current understanding is likely incomplete, a mere facet of a much larger, more complex truth. This intellectual humility is a powerful antidote to the rigidity that often fuels anxiety. The possibility of simulation, therefore, is not necessarily a source of despair, but a profound invitation to a new way of seeing. It is an invitation to embrace the mystery, to find peace not in definitive answers, but in the quiet wonder of the question itself. It allows us to let go of the desperate need for absolute certainty and to find solace in the elegant, perhaps even benevolent, design of whatever reality we inhabit. The shift is from demanding that reality be real in our limited human terms, to marveling at its existence, its complexity, and its inherent beauty, whatever its ultimate nature may be. This acceptance, this gentle surrender to the profound unknown, can be a deeply calming and ultimately peaceful experience. It is in understanding that even within a simulated framework, our experiences, our connections, and our search for meaning hold a unique and precious significance within the context of our existence. This contemplation invites us to see our perceived reality not as a prison of illusion, but as an intricate, perhaps even loving, creation, fostering a profound peace in the acceptance of its mysterious origins. The nature of truth itself becomes a fluid concept when we consider the possibility of a simulated reality. For centuries, humanity has grappled with defining what is real, what is true, and how we can definitively know it. Philosophers have debated sensory experience, the reliability of reason, and the very fabric of existence. If our universe is a simulation, then our perceived truths, our scientific laws, our historical accounts, and even our deepest personal feelings might all be emergent properties of a grander underlying code. The truth we experience would be the truth of the simulation, not necessarily the truth of the ultimate, fundamental reality in which the simulation exists. This doesn't invalidate our experiences, but it certainly reframes them. Our understanding of physics, for instance, would be a description of the rules of the game, not necessarily the fundamental laws of the simulator's own existence. The elegance and consistency we find in scientific principles could be a testament to the sophistication of the simulation's programming, designed to be internally coherent and observable by its inhabitants. The very act of seeking truth, of questioning, of striving for knowledge, could be an inherent part of our simulated nature, a drive programmed into us to explore and interact with our digital environment. This uncertainty about the ultimate nature of reality can, paradoxically, lead to a profound sense of liberation. If our current reality is not the absolute, fixed, and unchangeable bedrock we once believed it to be, then perhaps the anxieties and pressures we associate with it are also less absolute. The fear of failure, the sting of regret, the weight of existential dread, these might all be understood as phenomena within a specific context, a context that is itself open to redefinition. Our truth becomes not a fixed point, but a journey of discovery within the parameters we are given, and perhaps a subtle, ongoing exploration of those very parameters. The pursuit of knowledge, even if it leads to the conclusion that our knowledge is inherently limited by our simulated nature, is still a noble and meaningful endeavor. It is the exploration of the terrain we find ourselves in, and in that exploration, we find our own unique form of truth. The very act of questioning the nature of reality is in itself a profound act of consciousness, a spark of independent inquiry that transcends mere programmed response. It suggests a deeper layer, a capacity for reflection that might be more fundamental than we initially assume. Perhaps the truth we are meant to find is not an external, objective fact, but an internal understanding, a way of navigating our existence with wisdom, compassion, and a gentle acceptance of the unknown. The universe, whether simulated or not, presents us with an infinite canvas for wonder, and our perception of its truth is the brushstroke we choose to make. It invites us to embrace the ambiguity, to find beauty in the mystery, and to recognize that even within a simulated framework, our experiences, our connections, and our quests for meaning hold genuine significance. The truth of our existence might be found not in definitive answers, but in the courage to ask the questions and the grace to live with the profound uncertainty that lies at the heart of all being. This contemplation of truth, in the face of uncertainty, allows us to step back from the immediate pressures of our perceived reality and to gain a broader, more serene perspective. It is in this expanded awareness, this gentle questioning of what is real, that we can begin to loosen the grip of anxiety and find a deeper, more peaceful sense of self. The nature of truth, then, is not a rigid edifice, but a flowing river, and by understanding its potential fluidity, we can learn to navigate its currents with greater calm and acceptance. The profound realization that what we perceive as absolute truth might be a construct, a beautifully rendered illusion, can be a powerful catalyst for shedding the burdens of rigid expectations. It frees us to appreciate the present moment, the richness of our sensory experiences, and the depth of our connections, not as ultimate realities, but as precious and meaningful aspects of our current existence. The journey of seeking truth, even when it leads to more questions than answers, is itself a vital and enriching part of the human experience, a testament to our innate drive to understand, to connect, and to find meaning in the vast expanse of existence. This fundamental questioning, this inherent curiosity about the nature of reality, is a constant companion on our journey, a gentle reminder that the universe is far more wondrous and complex than our everyday perceptions might suggest. It is a call to embrace the unknown, to find comfort in the mystery, and to recognize that the pursuit of understanding in itself is a profound and deeply human endeavor. The exploration of truth in its many forms is a continuous unfolding, a process that enriches our lives and expands our understanding of our place within the grand tapestry of existence. Even if our reality is a simulation, the truths we uncover within it, the love we share, the knowledge we gain, and the beauty we perceive, are all valid and significant within the context of our experience. The uncertainty of ultimate reality does not diminish the value of our lived experiences. Rather, it invites us to cherish them all the more, recognizing their unique and profound beauty. The nature of truth in its most fundamental sense might be found in the very process of experiencing, questioning, and connecting, regardless of the ultimate substrate of our existence. It is an invitation to live fully, to love deeply, and to wonder ceaselessly, finding peace not in absolute certainty, but in the profound and ever-unfolding mystery of being. The quest for truth in its myriad forms is a journey that shapes us, expands us, and ultimately connects us to the deepest currents of existence, reminding us that even in uncertainty, there is profound beauty and an infinite capacity for wonder. And with this gentle exploration of the nature of truth, we find ourselves at a quiet juncture. Our calm journey through the fascinating, and sometimes unsettling, landscape of the simulation hypothesis has revealed a universe far more complex and intriguing than we might have initially imagined. We have peered into the potential digital architecture of our cosmos, considered the implications of quantum mechanics, and pondered the very definition of consciousness. Tonight, we have reviewed the principles of how our reality might be a meticulously crafted simulation, and in doing so, we have touched upon the philosophical underpinnings of what it means to be real, to know, and to seek understanding. This contemplation has offered a unique perspective, a gentle reminder that our perceived reality, with all its joys and its challenges, is but one layer of an infinitely complex existence. The anxieties and stresses that often weigh us down can begin to feel less absolute when viewed through this lens of cosmic possibility. They become phenomena within a specific context, a context that is itself open to redefinition and wonder. This understanding invites a profound sense of peace, a quiet acceptance of the vast unknown that surrounds us. It encourages us to find awe in the intricate workings of our universe, whether they are the product of natural laws or the deliberate design of a higher intelligence. The questions we've explored tonight are not meant to be answered definitively, but to be savored, to be contemplated in the quiet hours, allowing them to gently dissolve the sharp edges of our worries. Our existence, in whatever form it takes, is a magnificent and mysterious phenomenon, worthy of our wonder and our gentle curiosity. The universe, in its boundless majesty, offers us an endless field for exploration, and each question we pose, each insight we gain, is a step towards a deeper, more serene understanding of ourselves and our place within it all. The profound realization that our reality might be a simulation, far from being a source of distress, can be a gateway to a more profound appreciation of our present experiences. It allows us to cherish the beauty of the world around us, the warmth of human connection, and the simple moments of peace, knowing that their significance is not diminished by the potential nature of their origin. This perspective shift is a gift, a gentle invitation to release the tight grip of anxiety and to embrace the liberating embrace of wonder. It is a reminder that even in the face of profound uncertainty, there is an inherent beauty and meaning to be found in the act of living, of loving, and of seeking understanding. The quiet wonder we have cultivated tonight is a powerful antidote to the stresses of the waking world, a serene sanctuary for the mind and spirit. It is a testament to the power of curiosity to transform our perception and to guide us towards a state of calm acceptance. As we allow these thoughts to gently settle, we can begin to feel the weight of the day lifting, replaced by a sense of profound peace and quiet contemplation. The mysteries of existence are vast and beautiful, and our journey of understanding is an ongoing, unfolding marvel. Sleep well. Good night. It is time to rest now. If you happen to still be awake, you can drift into the next chapter now, allowing the gentle currents of curiosity to carry you further into the quiet wonders of the universe. Hello there, and welcome to the Scientist Sleepy. Our calm exploration has covered the profound questions surrounding the simulation hypothesis, inviting us to ponder the very fabric of our existence. Tonight, we have reviewed the principles of cosmic computer analogies, the intriguing implications of probability, and the subtle hints within quantum mechanics that might suggest a simulated reality. We've considered the fine-tuning of our universe, the nature of consciousness, and the philosophical quandaries that arise when we question the authenticity of our perceived world. We've gently touched upon the idea of glitches, the speed of light as a potential processing limit, and the mind-bending concept of simulations within simulations. This journey, though filled with questions, is not meant to unsettle but to offer a grander perspective. If our reality is indeed a simulation, it does not diminish the beauty of a sunset, the warmth of a loved one's hand, or the quiet joy of a starlit sky. These experiences, regardless of their origin, are real to us in this moment, and they hold their own intrinsic value. This profound contemplation can, perhaps, lessen the weight of our individual concerns, reminding us that we are part of a much larger, perhaps even unimaginably complex, tapestry of existence. The anxieties that may have kept you awake can seem smaller when viewed against the backdrop of such cosmic wonder. It is time to rest now. Let these thoughts gently dissolve like mist in the morning sun. Allow the vastness of the universe, whether simulated or fundamentally real, to lull you into a deep, restorative sleep. You are safe, you are curious, and you are comfortable enough to fall asleep. Sleep well, good night. It is time to rest now. If you happen to still be awake, you can drift into the next chapter now.